When NASA released the statement confirming that the interstellar object known as 3I Atlas would remain within our solar system, the scientific world was set ablaze with astonishment and excitement. For decades, astronomers have scanned the skies for foreign visitors from beyond the heliosphere, searching for clues about how other star systems form and evolve. The discovery of 3I Atlas, the third known interstellar object after 1I Oumuamua and 2I/Borisov, was already a historic moment. But the revelation that this object is not simply passing through, that it is staying, changes the landscape of planetary science, astronomy, and our understanding of cosmic migration in profound ways. Before we start, hit the like and subscribe buttons for more exclusive news. 3I Atlas had first drawn attention when its hyperbolic trajectory was detected by NASA's automated sky surveys. At first, the trajectory resembled that of previous interstellar objects, fast, elongated, and clearly influenced by no gravitational parent within our solar system. But as further measurements came in, scientists noticed subtle deviations. Its path began to curve ever so slightly, as though an unseen hand had tugged at it. Calculations revealed that 3I Atlas had not achieved the escape velocity necessary to leave the gravitational domain of the Sun. This meant it was now gravitationally bound to our solar system, a visitor from another star that had decided, in a sense, to stay. The implications of such an event cannot be overstated. For the first time in human history, material from a completely different stellar system has been captured by our own. It is as though a messenger from a distant cosmic civilization has chosen to linger, providing humanity with a sample of interstellar chemistry that might remain accessible for centuries. This isn't a fleeting chance encounter like Oumuamua, which vanished into the dark void beyond the Sun within months of discovery. 3I Atlas has entered into a stable, albeit eccentric, orbit, one that keeps it circling the Sun and interacting with the planets for generations to come. This development changes how scientists think about the architecture of our solar system. Traditionally, it has been viewed as a closed system, with an outer boundary defined by the Oort cloud and heliopause. But the capture of 3I Atlas demonstrates that this boundary is porous, capable of admitting objects from other stars under the right gravitational circumstances. NASA's data suggests that the object was slowed just enough by a rare confluence of factors: a near pass by Jupiter, subtle radiation pressure from the Sun, and possibly outgassing events that altered its momentum. The odds of such a capture were considered astronomically small, yet it has happened. 3I Atlas is an unusual object even by interstellar standards. Observations from NASA's James Webb Space Telescope and the ground-based Atacama Large Millimeter Submillimeter Array reveal a surface composition rich in carbonaceous materials and complex hydrocarbons. These organic compounds are not uncommon in comets, but their isotopic ratios indicate they formed in a different environment, under a different star. Scientists studying its spectral fingerprint have found that the carbon-to-oxygen ratio is unlike anything in our solar system, suggesting an origin in a protoplanetary disk with very different chemical dynamics. The presence of such alien material, now permanently within the solar system, is a goldmine for astrochemistry. Researchers can now study interstellar matter up close without having to send probes across light years. Missions are already being proposed to intercept and sample 3I Atlas, similar in concept to the OSIRIS-REx mission that visited asteroid Bennu. The opportunity to directly analyze material from another star system could answer questions about whether the building blocks of life are universal or specific to our own stellar nursery. As NASA's teams analyzed orbital data, they found that 3I Atlas has settled into a long, looping orbit that takes it from the outer solar system into regions just beyond Jupiter's path. Every several hundred years, it will swing closer to the Sun, warming slightly and potentially releasing plumes of gas and dust, miniature comae that could provide clues about its internal structure. During these perihelion passes, telescopes around the world will study its behavior, hoping to understand how interstellar bodies react to the solar environment. The capture also invites a reevaluation of how common such events might be. If 3I Atlas can be trapped by the Sun's gravity, then it's possible that many interstellar objects have been captured in the distant past and now reside undetected in the dark outskirts of the solar system. These could be hidden among the billions of icy bodies in the Oort cloud, masquerading as ordinary comets. The solar system may not just be a product of its own star's evolution, it could be a melting pot of material from across the galaxy. This idea transforms our understanding of cosmic history. It suggests that interstellar mixing might be a fundamental process in the evolution of planetary systems, with rogue objects serving as couriers of chemistry across stellar neighborhoods. For planetary defense experts, 3I Atlas presents both an opportunity and a challenge. Its foreign composition could behave unpredictably when interacting with solar radiation or gravitational forces. Understanding its structural integrity is crucial, because if such an object were ever perturbed into an Earth-crossing orbit, traditional impact models might fail to predict its behavior. Fortunately, current projections show that 3I Atlas poses no threat. Its orbit keeps it safely distant from the inner planets. But the lessons learned from monitoring it will refine planetary defense models and teach scientists how to handle future interstellar captures. The object's brightness and activity have also fascinated observers. While Oumuamua exhibited strange non-gravitational acceleration and Borisov resembled a typical comet, 3I Atlas falls somewhere between the two. Its coma is faint, almost ghostly, and it exhibits irregular bursts of brightness that suggest intermittent outgassing or surface shedding. This variability could be a result of its exposure to new solar radiation patterns, which differ from those of its home star. Each flare-up becomes a clue about how it formed, and how long it has traveled through interstellar space before being caught by the sun's gravitational web. From a dynamic standpoint, capturing an interstellar object is like catching a bullet in flight. For an object entering the solar system at tens of kilometers per second, the sun's gravity alone is not enough to retain it. It requires a delicate energy exchange, often involving a massive planet like Jupiter acting as a gravitational brake. In the case of 3I Atlas, simulations suggest it passed within several million kilometers of Jupiter, losing just enough velocity to drop below escape speed. Jupiter's immense gravity served as a cosmic net, slowing the interloper and redirecting it into a looping orbit. The precision of this event is staggering. It's a cosmic alignment of odds so improbable that it challenges our statistical models of celestial dynamics. The capture marks a turning point in our ability to study the galactic environment from within our own system. Instead of sending probes to distant stars, the stars have, in a sense, sent us material to study. 3I Atlas becomes a kind of bridge between solar and interstellar science, offering tangible evidence of how matter migrates through the Milky Way. Each atom within it carries a story written in isotopes and crystalline structures, a story that began around another star under alien conditions. Scientists can use this to reconstruct the chemical fingerprints of regions we may never physically visit. One of the most intriguing aspects of this event is the potential for biological implications. Not in the sense of life existing on 3I Atlas, but in how it could inform our understanding of panspermia, the hypothesis that life's precursors can travel between star systems aboard comets and asteroids. If organic molecules from another star system are preserved within the object's core, they could offer a direct test of whether such materials can survive interstellar journeys intact. The finding would have profound implications for how life might spread throughout the galaxy. The idea that the seeds of life could drift between stars, finding fertile ground on young planets, gains powerful support when an interstellar carrier becomes a permanent resident of our cosmic neighborhood. NASA's revelation also highlights how rapidly our observational capabilities have advanced. Detecting 3I Atlas was only possible because of the vast network of automated telescopes and space-based observatories scanning the sky continuously. Once considered science fiction, the idea of tracking interstellar debris in real time is now reality. The discovery showcases humanity's growing mastery of cosmic surveillance, our ability not just to see transient visitors, but to understand their origins and fates. The excitement extends beyond scientific circles. Philosophers and space enthusiasts alike have drawn parallels between 3Y Atlas's arrival and humanity's quest for belonging in the cosmos. The idea that something from another star has chosen, through the impartial laws of physics, to remain with us resonates deeply. It suggests that the solar system is not isolated but part of a grander network of stellar exchanges, a galactic ecosystem where stars and their planetary offspring interact in subtle, long-term ways. For engineers and mission planners, the event presents a tangible new target. Capturing a spacecraft rendezvous with 3I Atlas could provide unprecedented data on its surface composition, magnetic properties, and isotopic anomalies. Such a mission would push the limits of propulsion and navigation, requiring precise timing to intercept the object during one of its closer passes. The data gathered would not only deepen our understanding of interstellar materials, but also test technologies crucial for future interstellar exploration. It would be, in many ways, a rehearsal for sending probes beyond our own star. The naming of the object, 3I Atlas, reflects both its lineage and its discovery. The I stands for interstellar, the third of its kind, while Atlas refers to the asteroid terrestrial impact last alert system that first spotted it. The name carries symbolic weight, evoking the mythic titan who held up the heavens, fitting for an object that bridges the cosmic divide between stars. In the months following the discovery, NASA's team released high-resolution imagery and spectral analyses, revealing a rugged, tumbling body shaped roughly like a cigar, though more irregular than Oumuamua. Its rotation period appears chaotic, suggesting it has experienced collisions or tidal stresses during its long journey through space. Astronomers are still debating how long 3I Atlas has been traveling through interstellar space. Estimates based on its erosion rate and cosmic ray exposure suggest it may have wandered for hundreds of millions of years before encountering our solar system. It might have been ejected from a binary star system after a planetary disruption, or perhaps from the early stages of stellar formation elsewhere in the galaxy. Its capture here provides a snapshot of that distant past, like a fossil from another world delivered intact to our doorstep. The gravitational dynamics of its orbit also provide insight into the subtle balance of forces that govern the outer solar system. 3I Atlas's long-period trajectory suggests it will oscillate between regions near Jupiter and the farthest reaches of the Kuiper Belt, a vast region filled with icy remnants from the solar system's formation. Each orbit will slowly change due to planetary perturbations, radiation pressure, and the gravitational influence of passing stars. Over millions of years, it might settle into an even more stable orbit or be nudged outward again. For now, though, it remains ours, a captured relic from the galaxy beyond. The scientific curiosity surrounding 3I Atlas extends to its thermal and magnetic properties. Instruments have detected faint emissions in the infrared spectrum that indicate it retains a cold, dense interior despite solar heating. This resilience suggests a structure rich in volatiles locked beneath an insulating crust, similar to cometary nuclei but with unusual refractory compounds. The object's magnetism, faint though it is, could hint at a formative environment influenced by strong stellar magnetic fields. Studying these characteristics will help astronomers refine their models of planetesimal formation in different stellar nurseries. The psychological impact of this event on the scientific community cannot be ignored. When Oumuamua raced through and vanished, it left a lingering sense of unfinished curiosity. Humanity had, for the first time, glimpsed an emissary from another star, but only briefly. Now, with 3I Atlas staying, that fleeting window has become a permanent opportunity. The sense of wonder it evokes echoes the earliest days of astronomy, when people first realized Earth was not the center of the universe. Once again, we are reminded that the cosmos is not distant or detached, but alive with motion and connection. 3. I-Atlas also compels scientists to revisit theories about how the solar system formed. Some models suggest that our system may have captured interstellar material during its birth, as the Sun coalesced within a dense stellar nursery. If so, the capture of 3I Atlas could be a modern-day echo of that ancient process. It provides a direct example of how gravitational interactions between stars can exchange debris, enriching young systems with material diversity. This mixing could explain certain isotopic anomalies found in meteorites and comets, evidence that our solar system has always been part of a broader galactic dialogue. Even the trajectory of 3I Atlas itself tells a story of cosmic interplay. Its orbital inclination places it well outside the plane of the ecliptic, meaning it moves through space at a tilted angle compared to the planets. This makes it easier to distinguish from native objects and track its long-term evolution. Each orbital period will give scientists more data to refine their models of interstellar dynamics. Already, simulations are showing that the solar system's gravitational field acts as a kind of slow filter, occasionally trapping small percentages of interstellar objects while letting most slip through. Culturally, the news has reignited fascination with the idea of the interstellar neighbor. Artists, writers, and thinkers are exploring the symbolism of something foreign becoming part of our home system. It resonates with humanity's desire for connection beyond the confines of our world, suggesting that the universe itself is a shared space where boundaries blur. The presence of 3I Atlas becomes not only a scientific marvel, but also a philosophical mirror, reflecting our yearning to belong to something larger than our own planetary cradle. The confirmation that 3I Atlas is remaining within the solar system did not simply end with a single discovery. It opened a new era of inquiry that stretches across disciplines and philosophies. Every element of this object's existence within the sun's gravitational dominion invites deeper contemplation, from its physical behavior to the cosmic story it represents. For centuries, the solar system was understood as an isolated family of planets and minor bodies, born together from a swirling nebula of gas and dust. But now, the capture of an interstellar traveler redefines that story. It suggests that planetary systems are not self-contained at all. They are open, exchanging matter through the great galactic sea, carrying echoes of alien suns within them. 3I Atlas stands as both artifact and ambassador, a tangible link between worlds once separated by incomprehensible distances. The object's continued presence provides a living experiment in celestial mechanics. Its orbit, though stable, is unlike that of any known comet or asteroid. It traces a wide ellipse through the outskirts of the solar system, looping around the sun on a path that is neither fully circular nor dramatically stretched. The inclination of that orbit makes it pass far above and below the ecliptic, slicing across the plane of the planets at steep angles. Each crossing allows astronomers to study how the gravitational tides of the planets subtly nudge its path, reshaping it in ways that can only be observed over decades or centuries. This orbit is more than a mathematical curiosity. It is a fingerprint of the extraordinary chain of events that allowed the object to be captured in the first place. As 3I Atlas moves through its cycle, the solar wind sculpts its surface, whispering over the frozen terrain and gradually peeling away outer layers. These interactions create patterns of erosion unseen on native comets, because the material of 3I Atlas responds differently to radiation. Its crust may contain exotic compounds formed in another stellar nursery, ices hardened by ultraviolet light from a star that was smaller or hotter than our sun. As solar radiation warms the object, these ices release gases in bursts, producing faint asymmetric jets. These emissions act like tiny thrusters, gently altering its spin and trajectory. Every jet is a story, a chemical reaction sparked by a new environment, a dialogue between alien material and our familiar sunlight. The long-term observation of these phenomena offers a kind of chronicle of adaptation. Just as a biological species might evolve when placed in a new ecosystem, an interstellar object reveals its structural flexibility through its physical responses. The solar system becomes, in a way, its laboratory, testing its endurance against conditions it has never known before. Scientists have never had the opportunity to watch such a transformation unfold in real time. With each orbit, 3I Atlas will record the history of its exposure, its surface darkening under cosmic rays, its outgassing waning as the volatile materials diminish. In millions of years, if it remains, it may come to resemble the asteroids that were born here, a naturalized citizen of the solar domain, though its core will always bear the signature of another origin. Every telescope that turns toward it is aware that it carries information from another epoch of star formation. The proportions of deuterium and heavy isotopes inside its ices can tell scientists what kind of star once illuminated its birthplace. A young, hot star leaves a different isotopic pattern than a cool, long-lived one. If the ratios differ sharply from those in our own solar system, it confirms that the chemistry of planet building varies across the galaxy. This is crucial for understanding how common Earth-like worlds might be. If organic molecules can arise in many types of stellar nurseries, it strengthens the argument that the ingredients for life are widely distributed throughout the Milky Way. The idea that interstellar objects might act as seeds for planetary systems adds a poetic depth to this event. In the chaos of stellar birth, fragments are ejected at tremendous speeds, flung into interstellar space to wander indefinitely. Some are captured elsewhere, as 3I Atlas has been, introducing new materials into young systems. This process may enrich planets with elements they would otherwise lack. Carbon from one star, nitrogen from another. These exchanges create the chemical diversity that life depends upon. The discovery that such mixing still happens today means the galaxy remains a living, dynamic network, its stars connected through invisible threads of gravity and dust. In studying 3I Atlas, astronomers also confront the immense scale of time that governs such events. When the object first crossed into the sun's gravitational influence, human civilization was only beginning to map its own planet. Now that it is bound to our star, it will outlast all human institutions, orbiting long after the names of its discoverers are forgotten. It reminds us that cosmic processes unfold on timescales beyond imagination, where a single orbit can span centuries. In this context, the present moment becomes both fragile and vast, an instant within eternity, yet long enough to witness something no generation before could have seen. NASA's instruments have begun mapping the object in exquisite detail. Radar and optical imaging reveal a rugged topography, a landscape shaped by impacts and fractures. Some ridges rise like the crests of ancient waves frozen in motion, suggesting that the body once experienced intense tidal stresses, perhaps when passing close to another planet or binary companion before being expelled from its native system. There are also deep pits, likely formed by the explosive venting of gases trapped beneath the surface. Each scar tells of violent beginnings and cosmic exile, an odyssey written in rock and ice. As humanity watches this celestial visitor settle into its new role as a permanent neighbor, the object becomes a point of comparison for understanding our own solar relics. The asteroids, comets, and trans-Neptunian bodies that orbit our sun have long served as time capsules from the dawn of our system. But they all share a common origin. 3I Atlas, by contrast, brings a completely different story. Its material may hold patterns of molecular bonding unknown in our region of the galaxy. If these patterns can be analyzed directly, they could expand the known boundaries of chemistry itself. Perhaps new crystalline structures exist within its depths, stable forms of ice or carbon that could only develop under alien conditions. Discovering them would offer insight into how matter behaves across the vast range of stellar environments. This potential for discovery drives new mission concepts. Engineers envision probes that could rendezvous with the object, drill into its crust, and return samples to Earth. Such a mission would combine the precision of comet exploration with the complexity of interstellar research. Every gram of material retrieved would carry the essence of another world's chemistry, a message encoded in atomic structure. To design such a mission, scientists must first understand the object's exact orbit, rotational speed, and surface strength. These details are still being refined through radar echoes and photometric studies, each dataset narrowing the uncertainty. The surface reflectivity of 3I Atlas, its albedo, has also drawn intense interest. It reflects less sunlight than typical comets, giving it a dark, almost soot-like appearance. This suggests an abundance of carbonaceous material, possibly formed through prolonged exposure to cosmic rays in interstellar space. Over millions of years, high-energy particles would have bombarded its surface, breaking molecular bonds and reforming them into complex organic tars. Such space weathering transforms bright ice into a matte, coal-like crust. Beneath that darkened exterior, however, pristine ices may still lie untouched, preserving the chemistry of its birth environment. These layers are what scientists most hope to access. The capture of 3I Atlas also provides a unique opportunity to test models of gravitational resonance. When an object becomes trapped in the solar system, it often does so by falling into an orbital relationship with one of the giant planets. Jupiter and Saturn, in particular, act as gatekeepers, shaping the flow of comets and asteroids through their immense gravity. In this case, simulations indicate that 3I Atlas may be locked in a delicate resonance with Jupiter, completing a full orbit for every several that Jupiter makes. This resonance acts like a stabilizer, preventing close encounters that could eject it again. The fact that such a precise balance could occur reinforces the idea that the solar system's architecture naturally encourages the capture of wandering bodies, even if rarely. While much of the attention remains on scientific implications, the cultural and psychological impact of this revelation has been profound. Humanity has always looked to the stars with a sense of distance, imagining the space between suns as a void too vast for interaction. Yet here is proof that those distances are not absolute barriers. An object born under another sky has crossed the gulf and become part of ours. Artists have begun to depict 3I Atlas as a symbol of cosmic kinship, while writers explore its metaphoric resonance, a voyager finding an unexpected home, a fragment of elsewhere that now belongs here. It embodies the very essence of discovery, not conquest or possession, but connection. From a scientific perspective, the most immediate work lies in refining our understanding of its composition. Spectroscopy across multiple wavelengths continues to reveal a complex mixture of silicates, organics, and volatile compounds. Some absorption lines correspond to materials never before observed in the solar system, prompting debate about their exact identity. These substances may include forms of tholin, organic polymers created by radiation acting on simple molecules like methane and nitrogen. Tholins are known to color the surfaces of distant icy bodies such as Pluto and Titan, but the variants detected on 3I Atlas appear chemically distinct. This raises questions about the environmental differences between its birthplace and ours. Another remarkable aspect of this interstellar resident is its potential to inform theories about the frequency of such captures. The probability of a hyperbolic object slowing sufficiently to become bound is exceedingly small, yet not zero. Astronomers now believe that similar events may have occurred repeatedly throughout history, their remnants hidden in the outer solar system. If so, 3I Atlas could be only the first identified member of a larger population, a quiet fellowship of alien wanderers long ago caught in the sun's gravitational net. Detecting them would require extensive sky surveys focused on unusual orbits and isotopic compositions. Future telescopes, such as the Vera Rubin Observatory, may uncover more of these ancient visitors, revealing how interconnected stellar systems truly are. The interstellar nature of the object also raises questions about its magnetic signature. Planetary scientists suspect that some small bodies retain remnant magnetism from the fields of their parent stars. If 3I Atlas holds such a signature, it could act as a miniature record of the magnetic environment of a distant system. Measuring it would be extraordinarily challenging, as the signal is likely faint and easily masked by the solar magnetic field, yet even a trace detection would offer a window into conditions beyond our observational reach. In the realm of cosmochemistry, the isotopic ratios within 3I Atlas's material may reveal how diverse star-forming regions distribute heavy elements. Stars forge these elements through nuclear fusion, but the proportions of carbon, nitrogen, and oxygen vary depending on the star's age and mass. If the ratios within 3I Atlas differ significantly from those found in comets like Halley or Encke, it will provide tangible evidence that not all stellar nurseries produce the same chemical recipes. This diversity underpins the richness of planetary chemistry across the galaxy, influencing everything from atmospheric composition to the potential for life. Another layer of intrigue lies in the potential to use 3I Atlas as a calibration reference. By studying how it interacts with sunlight and the solar wind, scientists can refine models of how radiation affects interstellar objects in general. This knowledge will improve our ability to interpret the signals of distant exoplanets and circumstellar disks. Every observation of this object feeds into broader astrophysical understanding, linking small-scale behavior to galactic phenomena. For students of orbital dynamics, the capture represents a natural laboratory for chaos theory. Even small perturbations in 3Y Atlas's path can produce long-term variations that are difficult to predict precisely. These chaotic oscillations reveal how gravitational systems evolve over immense timescales. Tracking the object's movement year after year allows astronomers to test computational models of nonlinear motion, deepening their grasp of how planetary systems maintain stability despite constant interactions. The object's longevity within the solar system will also make it a subject of intergenerational study. Future astronomers centuries from now may still be observing its orbit, tracing its gradual evolution and compiling a dataset that spans human epochs. In this sense, 3I Atlas becomes part of humanity's long-term relationship with the cosmos. It is a reminder that science, unlike transient human endeavors, can create legacies that persist beyond the span of any single lifetime. Beyond the scientific frontier, there is a quiet philosophical transformation taking place. The permanence of 3I Atlas invites reflection on what it means to belong to a cosmic neighborhood. If material from other stars can become part of our system, then the boundaries that define us and them dissolve. The solar system is not merely a stage for human observation. It is part of a continuum of matter flowing through the galaxy. The object's orbit is a visible thread in that vast tapestry, connecting distant histories through shared gravity. In classrooms and planetariums, educators have seized upon this event as a way to inspire curiosity. The story of 3I Atlas captures the imagination of students who look up at the night sky and realize that one of those faint dots is not native to our sun. It embodies the idea that exploration never truly ends, that the universe still holds surprises waiting to be found. It also bridges the abstract and the tangible, a reminder that cosmic distances, though immense, can be crossed naturally, without technology or intent, through the silent laws of motion. The object's irregular shape suggests that it may once have been part of a larger body that fractured during ejection from its home system. Such an event could have occurred when its parent star underwent a gravitational encounter, or when a planet collided with another body, flinging debris into interstellar space. This violent origin gives 3I Atlas a tragic grandeur, a relic of cosmic upheaval now finding stability after eons of wandering. The fractures visible across its surface bear witness to that past, like the scars of a journey through the deep. As astronomers refine their understanding of how interstellar captures occur, they begin to see the solar system not as a passive recipient, but as an active participant in galactic dynamics. Every star's gravity influences its neighbors, subtly altering the trajectories of rogue objects. Over billions of years, these exchanges create a form of galactic mixing that ensures no star system is completely isolated. The Sun, therefore, becomes part of a living network, its gravitational field extending into that web of stellar interactions. 3I Atlas, in orbit around it, is the physical embodiment of this connection. For planetary modelers, the capture provides a natural experiment in orbital stability. By monitoring how 3I Atlas interacts with the known planets, they can refine simulations of how exoplanetary systems might capture and retain foreign bodies. This could help explain anomalies observed in other star systems, planets with eccentric or tilted orbits, debris belts with irregular distributions. The behavior of 3I Atlas offers a microcosm of the same processes on a smaller scale. There is also speculation that interstellar captures could play a role in transferring water or organic molecules between systems. If objects like 3I Atlas are common, they could serve as natural carriers of prebiotic materials, spreading them like cosmic pollen. The galaxy may thus be engaged in a slow but steady exchange of life's ingredients, enriching young worlds before life even begins. The fact that one such messenger now resides in our system lends new weight to this hypothesis. Astronomers studying 3I Atlas also find themselves contemplating its future. Over the next few million years, gravitational resonances may alter its orbit further, possibly bringing it closer to the Sun or even out toward the distant Oort cloud. Each scenario carries different implications. If it drifts outward, it may spend long epochs in cold darkness effectively preserved. If it moves inward, solar heat could awaken its dormant volatiles, transforming it into an active comet and reshaping its surface dramatically. Either path will be a natural evolution, one we have the rare privilege to witness from the beginning. What makes this event so compelling is that it exists at the intersection of science and wonder. 3I Atlas is a fragment of elsewhere, yet its journey and capture obey the same physical laws that govern every planet and moon. This unity of principle across such immense scales is the heart of astronomy. It shows that the universe is coherent, that the same equations hold true from the smallest dust grain to the grandest galactic orbit. Watching an interstellar body become part of our solar family is a vivid demonstration of that harmony. The object's name itself, though rooted in technical classification, has taken on symbolic meaning. Atlas evokes not only the survey that discovered it, but also the myth of endurance and strength, of bearing the weight of the heavens. It stands as a reminder that discovery is both a scientific and human act, combining curiosity, persistence, and imagination. The observers who first noticed its faint movement could not have foreseen that it would become one of the most significant astronomical finds of the century. From a cosmological standpoint, the presence of 3I Atlas strengthens the argument that our solar system is continuously interacting with the interstellar medium, Dust, radiation, and rogue bodies flow across its boundaries, blurring the line between inside and outside. The sun's magnetic field, which extends far beyond Pluto, forms a bubble that occasionally traps such travelers. 3I Atlas demonstrates that this bubble is not a barrier, but a dynamic gateway through which material can pass and sometimes remain. Even as 3I Atlas settles into its long and lonely orbit, the immensity of its significance continues to unfold in human thought. Its presence is not just an astronomical discovery, it is a shift in perspective about what it means for the solar system to be part of the galaxy. The sun and its planets were once imagined as an enclosed system, a family of bodies bound by gravity and sealed from outside influence. But the permanent capture of an interstellar object reveals something deeper. The solar system breathes. It exchanges material with the galactic environment, drawing in matter from beyond and perhaps releasing its own fragments outward in return. In that slow and ceaseless rhythm, the story of stars and worlds becomes one continuous narrative. 3I Atlas embodies the unity of the cosmos in a tangible way. Its origin lies among unknown stars, its path shaped by distant forces, its journey spanning epochs before it found rest here. The atoms that make up its body were forged in the furnaces of a star that lived and died long before the sun was born. In this way, 3I Atlas is a kind of messenger across time, carrying ancient starlight locked within its frozen minerals. Every molecule on its surface has endured the silence of interstellar space, where radiation and dust sculpted its chemistry for millions of years. Now, those same molecules glisten under our sun, warming faintly in a light they have never known before. When telescopes record its faint glow, they capture more than reflected sunlight. They capture an encounter between two stellar histories. For scientists, this is the most extraordinary aspect of all, a direct physical connection between the evolution of our solar system and another. In a universe where stars are separated by incomprehensible distances, the presence of an interstellar visitor that has chosen to stay is a bridge across those chasms. It is as though two cosmic rivers, each flowing from separate origins, have briefly joined their currents. The details of how 3I Atlas was captured are still being refined, but simulations show a dance of breathtaking precision. The object entered the solar system at high velocity, likely at an angle nearly perpendicular to the plane of the planets. It was drawn toward the sun, but passed close enough to Jupiter to experience a gravitational exchange that slowed it down. For a moment, it was poised between escape and capture. The great planet's mass bent its trajectory just enough that the sun's gravity took hold. That tiny shift transformed a traveler of the galaxy into a permanent member of our stellar neighborhood. What makes this so astonishing is that among countless interstellar wanderers that pass through, almost none meet the conditions to remain. The universe conspired, in a sense, to let this one stay. Now that it is part of the solar system, 3I Atlas follows a path that will intersect the gravitational influence of multiple planets over time. Its orbit will oscillate, sometimes slightly elongating, sometimes tightening. These changes are predictable in the short term but become chaotic over millennia. The delicate interplay of planetary tugs and solar tides ensures that its motion will always carry traces of unpredictability, a celestial echo of its restless history. Yet even within that chaos, there is harmony. The solar system has found a way to accommodate an outsider, folding it into its pattern like a stray note that somehow completes a symphony. The arrival of 3I Atlas has prompted astronomers to reconsider the boundaries of our system. The Oort cloud, that vast sphere of icy debris far beyond Pluto, has long been thought of as the frontier between our sun's domain and interstellar space. But the presence of a captured interstellar object suggests that the boundary is not static. Material from other stars can cross it, linger, and merge. This dynamic exchange may mean that the outermost regions of the solar system are not purely native. Some of the comets that occasionally dive toward the sun may themselves be of foreign origin, captured billions of years ago and only now revealing themselves as the gravitational tides shift. If this is true, then the sun's entourage of icy wanderers could be a mosaic of the galaxy itself. The scientific importance of this realization is profound. It means that by studying comets, asteroids, and bodies like 3I Atlas, humanity can sample the chemical diversity of the Milky Way without leaving home. Each interstellar capture becomes a preserved specimen of a different cosmic laboratory. Within its structure are clues about the temperature, density, and radiation levels of its native stellar nursery. Such information cannot be gained by telescope observation alone. It must be touched, analyzed, tasted by instruments that can measure its isotopes and molecular arrangements. When scientists speak of sending probes to 3I Atlas, they are really speaking about traveling into another star's past. The challenge, however, is monumental. The object's orbit takes it into regions of space where sunlight is faint and communication with Earth is delayed. Any mission would require power sources that can operate far from the sun, and navigational precision capable of intercepting a body that moves unpredictably. Yet this difficulty only adds to its allure. Human ingenuity thrives on such frontiers, and 3I Atlas offers a target that tests the limits of engineering and imagination alike. The first mission to a captured interstellar body would mark a new chapter in exploration, humanity's first visit to something that was once part of another star system. The discovery has also deepened the philosophical implications of our cosmic existence. For centuries, people have wondered whether life could exist elsewhere, and how it might arise. 3I Atlas cannot answer those questions directly, but it provides the first tangible link between solar systems, a physical example of how matter travels from one stellar cradle to another. If organic molecules are found within it, as preliminary spectroscopy suggests, they would confirm that the ingredients for life are not confined to any single region of space. They drift freely across the galaxy, carried by comets and fragments like seeds in a cosmic wind. The same molecules that shaped biology on Earth could have analogs forming under different suns, evolving along parallel paths unseen by us. This realization transforms the notion of isolation into one of continuity. The Milky Way is not a collection of separate worlds, but a single living system of exchange. Stars create elements, planets form from their debris, fragments escape and carry those elements elsewhere, where they may begin new stories. 3I Atlas is a physical reminder that our origins are intertwined with those of distant stars. The carbon in our bodies and the oxygen in our lungs were forged in ancient stellar explosions, just as the materials inside that object were. In a very literal sense, it is family returning home. The data gathered from this object will refine many scientific models, for example, by comparing its reflectivity and spectral emissions to known solar system bodies. Researchers can calibrate the rate at which interstellar radiation alters the surfaces of small objects. They can determine how long 3I Atlas has traveled between stars based on the depth of radiation damage in its outer layers. Its rotation and wobble can reveal internal density variations, helping to infer whether it is a solid mass or a loose agglomeration of dust and ice. Even its color carries meaning. Subtle differences in hue reveal the complex chemistry of carbon chains, silicates, and iron-bearing minerals. Each measurement peels back another layer of its cosmic biography. As astronomers chart its orbit, they have also found that its period resonates with patterns in the outer solar system. It seems to avoid collisions or close encounters, as though guided by invisible corridors of stability. These corridors, carved by gravity, are pathways that shape the motion of countless small bodies. Understanding them will help explain how planets and asteroids migrate over time. It is possible that such resonant zones exist in other star systems as well, guiding the flow of debris and perhaps even influencing where habitable planets form. The lessons learned from 3I Atlas extend far beyond its own orbit. They illuminate universal processes. On a more human level, its presence has reignited a sense of cosmic wonder that had faded somewhat in the routine of modern observation. Astronomers spend countless nights scanning for faint dots, cataloging data, and measuring orbits. Yet when something like 3I Atlas appears, the numbers come alive. It reminds them why they look upward at all, not merely to collect data, but to encounter the unknown. The moment of confirmation that it would remain in the solar system carried a thrill that rippled through observatories worldwide. Scientists who have devoted their lives to studying the heavens felt the rare joy of witnessing a true first in human history. For the public, the idea that a piece of another star system is now orbiting our sun captures imagination on a grand scale. It has become a topic of art, film, and poetry. People see in it a reflection of themselves, a traveler far from home, finding a place in a new realm. The symbolism is powerful. It speaks to the universality of exploration, the shared desire of all beings to journey beyond boundaries. Just as the object has crossed from one star to another, so humanity dreams of doing the same one day. In that way, 3I Atlas becomes both mirror and muse. In laboratories, meanwhile, scientists are already preparing instruments that could study it in greater detail. Laser spectrometers, particle analyzers, and cryogenic collectors are being designed to survive the conditions it presents. The potential rewards are enormous. If isotopic anomalies are found within its material, they could redefine our understanding of how matter evolves between stars. The ratios of hydrogen to deuterium, for example, might differ drastically from those seen in comets born of the solar nebula. That would confirm not only its alien origin, but also the diversity of cosmic chemistry. Each finding would add a new line to the story of galactic evolution, written not in theory, but in measurable fact. Its magnetic and gravitational characteristics also open doors for research. Even small variations in how it interacts with solar wind particles can reveal the electrical conductivity of its surface. This, in turn, hints at the presence of metallic minerals or frozen gases beneath. By mapping how its tail responds to solar activity, scientists can deduce the microstructure of its dust. These observations are not trivial. They feed into models that describe how interstellar dust behaves throughout the galaxy. That same dust, in aggregate, is what obscures distant starlight and shapes the infrared glow of the Milky Way. Understanding one object can thus illuminate the behavior of billions. The existence of 3I Atlas also influences theories about planetary defense. Though it poses no threat, studying its trajectory helps refine methods for predicting the paths of objects with unusual origins. If interstellar bodies can become bound to the Sun, then similar objects could one day enter orbits that cross Earth's path. Knowing their composition and motion helps build better systems for tracking and mitigation. It's a strange twist of fate that a discovery made for curiosity also enhances safety. But that is the nature of knowledge. It strengthens humanity in ways not always foreseen. From a cultural viewpoint, 3I Atlas has already become a symbol of cosmic heritage. It represents the merging of scientific insight and mythic imagination. Civilizations throughout history have looked to comets as omens, messengers, or signs of transformation. Now, in a modern context, this one truly is a messenger from another star, bearing real physical evidence of worlds beyond. Its story connects ancient awe with modern reason, showing that wonder need not be abandoned in the pursuit of understanding. The same curiosity that once led people to chart the stars now guides robotic telescopes and space probes, each extension of the same eternal impulse to know. In classrooms, students learn about gravity, motion, and chemistry through the lens of this discovery. It has become a teaching tool as well as an inspiration. Teachers explain how minute gravitational forces can trap an interstellar object, how chemical spectra reveal unseen compositions, how orbital resonance maintains stability. For young minds, 3I Atlas is not a distant abstraction, but a story unfolding in their own time, a chance to see science happening before their eyes. It reminds them that discovery is not confined to the past. It is an ongoing process in which they may one day take part. Some researchers speculate that 3I Atlas may help explain anomalies in the solar system's own chemical distribution. Certain meteorites found on Earth contain isotopic patterns that do not fit the known profile of solar materials. They may have originated from captured bodies like this one, ancient precursors absorbed long before recorded history. If so, then 3I Atlas could serve as a model for understanding these mysterious relics. It would show that our planet itself carries within it traces of interstellar heritage, locked in stone since the dawn of time. There is also the intriguing possibility that its capture could slightly alter the balance of mass and momentum in the solar system. Although minuscule, every addition to the Sun's retinue influences its center of mass. Over eons, such cumulative effects could play a subtle role in planetary alignments or the distribution of cometary reservoirs. It is a reminder that even a small object under the right conditions contributes to the evolving harmony of celestial motion. Astronomers tracking 3I Atlas are keenly aware of the delicate beauty in its motion. When plotted against the background of the stars, its path forms an elegant curve that winds through the constellations, a luminous thread stitching the sky together. Each observation adds precision to its ephemeris, refining predictions for where it will appear in future decades. Amateur astronomers have begun photographing it, their images circulating across the globe, uniting people under a shared sky. For all its scientific depth, the object's most immediate gift may be this: it draws humanity together in collective wonder. As time passes, the study of 3I Atlas will expand into new realms. Scientists will attempt to model its internal structure, imagining how heat from the sun propagates through its body, how cracks form and close, how sublimation reshapes its contours. They will simulate its collisions with microscopic dust and its interactions with the magnetic field of the heliosphere. Each model brings them closer to understanding how such objects survive the immense stresses of interstellar travel. Those insights will be vital for future missions that seek to send probes beyond the sun's influence, for the same physical laws govern all travelers through the void. The endurance of 3I Atlas stands as testimony to the resilience of matter itself. It has crossed environments of unimaginable hostility, frozen darkness, radiation storms, gravitational tides, and yet remains intact enough to tell its story. It is a survivor from another age, a silent monument to the persistence of cosmic material. In that sense, it reflects the same resilience found in life on Earth, which endures through transformation and adversity. The parallel is striking. Both life and matter persist by adapting, by changing just enough to endure. Each time it approaches the sun, its surface will change slightly, shedding thin veils of dust that drift into space. Those particles will join the zodiacal light, the faint glow seen before dawn and after dusk, where sunlight reflects off cosmic dust. Future observers may look at that glow without realizing that some of its dust comes from 3I Atlas, tiny fragments of another star, now intermingled with the breath of our own. Thus, even as the object continues its long orbit, it will share pieces of itself with the solar system, blending its story with ours at the most intimate scale. It is easy to think of 3I Atlas as an exception, a rare curiosity, but it may instead be a reminder of what is ordinary on the grand scale. The universe is filled with motion. Stars form and die, planets scatter, debris drifts endlessly. That some of it should cross paths is not extraordinary, it is inevitable. What is extraordinary is that humanity is here to witness it, to recognize the significance, and to name it. For billions of years, such captures must have occurred unnoticed. Now, in the brief moment of human consciousness, we can see and understand the pattern. The permanence of 3I Atlas within the solar system changes how scientists think about cosmic history. It suggests that the Milky Way is not merely a field of isolated systems, but a living continuum of exchange. Each captured object becomes a record of that interstellar dialogue, a page in the book of galactic evolution. To read that book requires patience, precision, and imagination, the same qualities that have driven astronomy from its beginnings. In that sense, 3I Atlas is both discovery and invitation. It invites humanity to look deeper, to continue the search for others like it, and to recognize that the universe is not silent, but filled with stories waiting to be heard. The steady revolution of 3I Atlas around the sun now continues as a quiet heartbeat within the solar system, a rhythm so slow and grand that it transcends all human measurement of time. Each arc of its orbit is a curve of memory, a celestial testimony to distances so immense that no story can capture them in full. The object's mere existence in a stable path around our star represents a harmony between two forces, the gravitational will of the sun and the stubborn momentum of a traveler forged under alien skies. That balance is exquisite, almost poetic, a dance of numbers and physics that becomes, to the mind's eye, something like music. The longer scientists observe it, the more its nature unfolds in subtler layers. There are faint shifts in brightness as it rotates, a slow and uneven flicker that betrays its shape and surface features. From those variations, astronomers have constructed models suggesting that 3I Atlas is neither spherical nor elongated in the simple way of many asteroids, but a complex angular form, perhaps fractured into lobes, like a frozen hourglass joined by a narrow bridge of rock and dust. Such a shape implies a history of collisions and reassembly, a body that once shattered and then recohered under its own weak gravity. It may carry within it the scars of countless impacts, each one a mark of its passage through chaotic regions of its original system before being hurled into the interstellar void. Each lobe may have its own composition like two geological epochs fused together. One could be rich in metallic minerals, while the other might contain volatile ices that still sublimate faintly when sunlight grazes their surface. The narrow neck between them could act as a venting point where gases escape, creating momentary jets that twist the object's rotation slightly. If so, its spin would not be regular. It would precess, wobbling like a slowed top on a table. This irregular motion would complicate any attempt to land a spacecraft there, but it also provides valuable information about its internal structure. A solid core behaves differently from a loose rubble pile when torques are applied. Tracking the wobble over years will tell scientists whether it is monolithic or porous, crystalline or granular. There is a quiet marvel in the thought that its substance, whatever minerals and ices lie inside, was born under a completely different spectrum of starlight. Somewhere far across the spiral arms of the Milky Way, another star shone upon it. Its wavelengths, perhaps bluer or redder than our sun's, shape the molecular bonds that now rest within its frozen crust. That ancient starlight is gone, the star itself possibly evolved or dead, but its influence survives inside 3I Atlas, fossilized in chemistry. It is as though a distant sun has left a signature within the solar system, a relic of a stellar ancestry we can only imagine. To analyze its materials, then, is not just to study rock, it is to read the echoes of a long-vanished star. When light from our sun now strikes it, it begins a new dialogue. Photons that were born in the core of our star after hundreds of thousands of years of diffusion now travel through space, touch this alien object, and scatter back toward Earth. In each reflection is a meeting of two stellar histories. The idea that such an exchange can be measured, cataloged, and understood through physics and chemistry shows how deeply humanity has learned to listen to the universe. Every spectral line, every data point, becomes a bridge between distant epochs. The capture of 3I Atlas may also help explain a long-standing mystery in astrophysics, the exchange of solid matter between stellar systems. It has long been known that during the early formation of stars, gravitational interactions are violent and chaotic. Disks of gas and debris overlap, flinging small bodies outward in great numbers. But how many of those bodies survive their ejection, and how often they are captured elsewhere, has been uncertain. The presence of a captured object now orbiting our sun offers a rare calibration point. It proves that transfer is not only possible but observable, and it gives scientists a starting reference for estimating how much material migrates across interstellar distances. The implications stretch far beyond our system. They suggest that the galaxy as a whole operates as a vast engine of redistribution. Every stellar nursery contributes to the shared inventory of cosmic matter, and every mature system gathers from that common pool. This idea resonates with the broader concept of galactic ecology, a view of the Milky Way as an interconnected organism of energy and substance. Just as ocean currents mix the waters of Earth, gravity mixes the materials of stars. 3I Atlas is a tiny visible eddy in that current, a particle caught in the swirl of forces that binds the galaxy together. When it crossed into the solar system and stayed, it carried with it an invisible trail of the interstellar medium, dust grains, ions, and radiation patterns distinct from the sun's domain. Its presence allows instruments to directly measure how those two environments interact. The solar wind's boundary, where charged particles from the sun meet those of deep space, can now be tested against a solid object of known interstellar origin. It becomes a living probe of the heliosphere itself, moving through regions that spacecraft rarely reach. The interaction of 3I Atlas with the solar wind will gradually alter it. Its surface is bombarded by high-energy particles, which sputter atoms from its crust and implant others from the flow. Over centuries, this process will create a kind of hybrid surface, partly solar in character, partly interstellar. The outermost layer will become a thin film of mixed heritage, a literal blending of worlds. Future missions that sample it could, therefore, trace a timeline in its surface composition. Deeper layers telling of its ancient birthplace, outer layers recording its life within our sun's reach. From an observational standpoint, one of the most fascinating aspects is how faint it remains. Even though it resides within the solar system, it is invisible to the naked eye, a whisper of light lost among the stars. This subtlety carries its own meaning. The universe's most profound truths are often not spectacular explosions or dramatic displays, but quiet continuities, small objects moving through vast emptiness, altering our understanding by their mere persistence. The fact that 3I Atlas endures unseen yet significant mirrors the way science often works, through patience, precision, and the slow accumulation of insight. As instruments continue to refine their measurements, astronomers will attempt to determine the object's thermal properties. Because it spends most of its orbit far from the sun, its temperature hovers near the absolute limits of cold, but each perihelion passage warms it slightly. That cyclical heating may cause sublimation deep within, creating internal pressure that reshapes its outer layers. Some researchers propose that cavities might form, filling with vapor until they rupture, releasing bursts of gas that propel the object gently like miniature rockets. Over time, such outbursts could subtly shift its trajectory, changing its orbit by imperceptible degrees. Detecting these minute changes will require decades of observation, but they may reveal the processes by which interstellar comets evolve once captured. Within these processes lies a reflection of the larger cosmic balance between energy and rest. Every orbit is a compromise between motion and containment, between the pull of the sun and the memory of freedom. For 3I Atlas, that balance will last for ages. It is neither fully domesticated nor truly wild. It moves between those states like a wandering spirit bound at last by an unseen tether. This duality, belonging yet alien, gives it a strange poetic allure. It is of the solar system now, yet never of it in origin. It belongs to two histories simultaneously, and in that overlap lies its meaning. Speculations have emerged that studying this object might even help refine the search for exoplanets. The composition of its materials could reveal information about the kinds of planetary disks that form around stars similar or dissimilar to the Sun. If its isotopic ratios suggest that it formed near a cooler red dwarf, scientists might look for worlds around such stars that share its characteristics. Conversely, if its chemistry indicates a massive hot star, it could explain why such systems might eject material more readily. In this way, one frozen fragment becomes a diagnostic tool for understanding entire families of distant planets. The discovery also stirs deeper currents of thought about cosmic inheritance. Every object captured, every grain of dust drawn in, becomes part of the solar system's legacy. The planets, moons, and smaller bodies continually interact with material from beyond. Meteorites fall upon Earth, adding atoms that once belonged to other stars. Now, on a larger scale, 3I Atlas circles as a macrocosmic symbol of that same process. It reminds humanity that creation is ongoing. The sun is not a closed parent. It continues to gather, to integrate, to grow in subtle ways that connect it to the galaxy's flow. There is a serene grandeur in realizing that the solar system itself is still evolving, not merely through planetary motion, but through exchanges like this, minute, steady, and unending. The cosmos is not static. It breathes and circulates, redistributing its matter over billions of years. Our sun, like all stars, is part of that slow respiration. When it captures a traveler such as 3I Atlas, it takes in a fragment of that universal breath. The object's arrival may also deepen humanity's emotional connection to the cosmos. In every age, people have sought symbols to express their longing for the infinite. Now, without myth or superstition, 3I Atlas serves that role. A physical, measurable wonder that evokes awe not through mystery, but through revelation. It embodies the same spirit that drove the first astronomers to chart the heavens. The intuition that the universe is alive with relation, that everything moves together in one vast unfolding design. In practical terms, it will take centuries before 3I Atlas completes even a few full circuits of its new orbit. Long after the scientists of today are gone, their descendants will still be tracking it, updating its path with new instruments, perhaps visiting it with autonomous probes or swarms of nanobots. The data those future missions collect will continue the work begun in our time, expanding the record of human understanding. It is an inheritance for the future, a project whose full story will take millennia to write. The surface of 3I Atlas, imagined through telescopic data, may already hold landscapes unlike anything known in the solar system. Jagged cliffs of carbon ice, smooth plains of frozen hydrocarbons, perhaps veins of crystalline ammonia glinting faintly in the reflected light of the distant sun. There might be crevices so deep that no light reaches them, filled with ices compressed into exotic states by eons of cold. These frozen minerals are time capsules, preserving the conditions of a star system we may never see. Each grain of dust inside those layers once floated in a cloud of gas around a distant sun before gravity bound it into a solid world. When we touch that material, we touch the history of another sky. The quiet revolution this represents in science is difficult to exaggerate. For generations, astronomy was a discipline of observation from afar. With the moon and nearby planets, humanity crossed the boundary between seeing and touching, but always within our own system. 3i Atlas offers the first chance to bridge that gap on a galactic scale. It is not simply that we will study something from elsewhere, it is that elsewhere has come to us. The universe has delivered a specimen from beyond, free of charge, ready to be examined by the minds that arose under this sun. In the deeper sense, that meeting redefines perspective. The galaxy, once an abstraction of remote stars, now feels nearer, tangible, connected through gravity and matter. The interstellar gulf is no longer an unreachable expanse, it is a corridor through which worlds exchange gifts. 3i Atlas, in its silence, proves that cosmic distances are not barriers to interaction but part of the same continuous space. Humanity stands at the intersection of that continuity, aware for the first time of being both local and galactic beings. The more that thought settles, the more it changes how we imagine ourselves. Earth is no longer just one planet orbiting a sun. It is part of an ecosystem of stars exchanging dust and stone. The human species, made of atoms that once belonged to countless generations of stars, has now found in 3i Atlas a living example of that kinship. The object's endurance through unimaginable distances mirrors our own persistence as thinking creatures reaching outward in curiosity. It seems almost symbolic that just as humanity begins to dream seriously of interstellar travel, an interstellar traveler arrives unbidden to share our sun. One can imagine future generations standing on Mars or the moons of Jupiter, watching the faint light of 3i Atlas through telescopes, knowing it is the first permanent interstellar guest. They might launch missions to orbit it, to bore into its crust, to analyze its gases as they escape. Those missions will not be driven only by scientific necessity, but by the same ancient impulse that once sent ships across oceans, the desire to see what lies beyond the horizon. The name 3i Atlas may become part of their folklore, a symbol of arrival and unity. Even the physical dynamics of its capture inspire awe. The mathematics describing how a high-speed interstellar body can lose just enough velocity to be retained by a star are intricate beyond easy visualization, yet the universe performs them effortlessly. The precision required is staggering. The timing of its entry, the exact distance from Jupiter, the alignment of vectors and masses, one deviation, even by a fraction of a percent, and it would have passed through forever, vanishing into darkness. That it did not suggest that the cosmos is far more interactive than random chance might imply. Gravitational relationships weave an unseen network across space, and occasionally, those threads tighten to create lasting connections. As humanity reflects on that, a broader understanding of existence emerges. The same gravitational law that binds an apple to Earth also binds a comet from another star to our sun. The unity of physics across all scales gives meaning to our observations. It reveals that the entire cosmos operates under shared principles. 3. I-Atlas is evidence of that continuity, a tangible affirmation that the universe is one coherent whole. Perhaps most profoundly, its endurance challenges the boundaries of time as well as space. The object has existed for hundreds of millions of years, traveling silently before being noticed by minds that evolved only recently. Its presence reminds us how young we are in cosmic terms, and how much remains unseen. Yet it also affirms that awareness has emerged within the universe capable of recognizing these vast processes. In seeing 3i Atlas and understanding what it is, humanity closes a loop of perception, the universe observing itself through conscious beings. For poets and philosophers, this realization will echo long after the scientific data has been cataloged. The captured interstellar wanderer becomes a symbol of belonging and transformation, a reminder that even the most solitary traveler can find a home, and that the universe itself is hospitable to connection. It tells of a cosmos not cold and indifferent, but woven with the potential for meeting, for convergence. It tells us that every journey, no matter how long, may eventually find its orbit, And so 3I Atlas moves on unseen by most, yet changing everything it passes. The sunlight that touches it now has begun to reshape its surface, engraving new patterns atop the old. Micrometeoroids will strike it, leaving fresh craters. Solar wind will polish its ridges and darken its hollows. Bit by bit, it will adapt to its new star. In that slow transformation, it becomes a metaphor for the universe itself, forever in motion, forever becoming, never still. There will come a time, perhaps millions of years from now, when another intelligence, human or otherwise, studies it and learns of its journey. They will find traces of the solar dust it has gathered, layers of cosmic records spanning eons. They will see that it was once alien and became native, that it carried the chemistry of one star and absorbed the light of another, and perhaps they will see themselves in it. Wanderers who crossed space in search of meaning, finally finding it not in distance, but in connection. For now, though, it circles quietly. Its orbit is a thread drawn through the great tapestry of the solar system, a reminder of the vast unity of things. Every particle that escapes from its surface joins the stream of solar dust. Every photon it reflects travels outward, mingling with starlight. It has ceased to be only an outsider. It is part of the story now, written into the ongoing chronicle of our star's domain. That permanence, fragile, slow, immense, is what gives 3I Atlas its enduring wonder. It is not the drama of arrival or the spectacle of discovery that defines it, but the calm persistence of existence across impossible distances. In its silence, in its orbit, it speaks of the universal continuity of all matter, all motion, all being. It shows that the gulf between stars is not an end, but a bridge, and that every object, no matter how far it has traveled, carries within it the memory of the cosmos entire. The stillness of 3I Atlas against the vastness of the cosmic backdrop seems deceptive, for beneath that silence is motion on a grand and unending scale. Its orbit, though invisible to most eyes, is a path written into the architecture of the solar system, a pattern that will persist long after the continents of Earth have shifted, after the oceans have evaporated, after human memory itself fades. Each second that passes carries it forward on that curve, drawing a slow, luminous thread around the sun. The mathematical perfection of its motion conceals a deeper story, one that began before our star was even born, the tale of how matter, once scattered through interstellar space, now circles within a new gravitational home. The persistence of 3I Atlas within the sun's influence has become a kind of cosmic experiment, unfolding not in laboratories, but in the living environment of the solar system itself. Scientists, artists, and thinkers alike find themselves drawn into its story, not only for what it teaches about celestial mechanics or chemistry, but for what it reveals about the connectedness of existence. Here, in one small silent object, the lines between here and there, between ours and theirs, between beginning and end, dissolve. It is proof that the boundaries humanity draws are only temporary conveniences. Nature itself does not recognize them. In the decades since its capture, astronomers continue to measure its orbit with increasing precision. They have discovered that it is influenced not only by the major planets, but by the collective gravitational pull of smaller bodies, asteroids, trans-Neptunian objects, even the distributed mass of the Kuiper Belt. Each of these minute forces adds a subtle vibration to its path, making its orbit a tapestry woven by countless invisible threads. The solar system is not a static clockwork, but a breathing structure, pulsing with mutual influence. Every particle affects every other, however slightly, and 3I Atlas now participates in that living network. Its capture is also altering how humanity defines permanence in space. Nothing remains entirely untouched in the cosmos. Everything interacts. The realization that an interstellar traveler can become bound, even for millions of years, to another star challenges the notion of cosmic solitude. The Milky Way is full of exchange, matter drifting between stars like pollen between flowers. Each act of capture and release is a whisper of the galaxy's continuity. Perhaps one day, long after our own sun fades into a white dwarf, fragments of its planets and asteroids will wander outward and become guests in other stellar systems, just as 3I Atlas has done here. The process is eternal, and we are fortunate to have witnessed one instance of it. Its orbit cuts across the known regions of the outer solar system, grazing the gravitational influence of Jupiter and Saturn before extending toward the icy frontier. At aphelion, when it is farthest from the Sun, 3I Atlas drifts in darkness so deep that the Sun appears only as a brilliant star among billions. There, the temperature plunges to nearly absolute zero, and even light moves sluggishly through the scattered dust. Yet even in that frozen exile, the object carries energy within it, the slow heat of radioactive decay, the faint residual warmth of its long history. Every atom vibrates slightly, each movement a reminder that absolute stillness is an illusion. Closer to the Sun as it sweeps through its inner arc, the faint warmth awakens its surface. Spectral observations reveal that small jets erupt intermittently, throwing out tendrils of dust that reflect sunlight in ghostly halos. These eruptions are weak compared to those of typical comets, but they create a thin envelope, a shimmering cloud of microscopic grains that glows faintly in the blackness. The cloud disperses quickly, leaving behind a faint trail that joins the endless ribbon of cosmic dust circling the Sun. Over the millennia, that trail will blend into the interplanetary medium, spreading material from another star throughout our system. In this way, 3I Atlas participates in the ongoing exchange of matter that shapes the solar environment. When astronomers study those dust grains through telescopic polarization filters, they find that they scatter light in unusual patterns. This suggests the grains are irregularly shaped and possibly composed of exotic compounds unfamiliar in our region of space. Some models indicate the presence of amorphous silicates and nitrile polymers, materials that could have formed under colder or more nitrogen-rich conditions than those that existed in the early solar nebula. Such findings extend the known diversity of cosmic chemistry. They tell us that not all planetary systems follow the same chemical recipes. Each star forges its own versions of dust and ice. The galaxy is not homogeneous, but a patchwork of chemical dialects, each with its own accent, each capable of producing different outcomes. Scientists studying planetary formation see in 3I Atlas a laboratory for understanding how systems evolve differently. Its existence implies that small bodies can migrate between systems, meaning the building blocks of one world might seed another. If interstellar mixing is common, then the early solar system likely incorporated foreign material as well. This could explain peculiar isotopic signatures found in ancient meteorites, tiny anomalies that hint at origins beyond the solar birth cloud. By comparing those meteorites to the future samples of 3I Atlas, researchers hope to reconstruct a more accurate portrait of how our system assembled. Perhaps we were never purely of this star alone. Perhaps the Earth itself, in part, was shaped by dust that came from another sun. Such insights carry a quiet philosophical power. They suggest that the boundaries of identity, whether planetary or personal, are fluid, ever in flux. Just as 3I Atlas carries the memory of two stars, so too does humanity carry the heritage of countless cosmic events. Every breath we take, every atom of carbon and oxygen within us, once traveled through the interiors of stars that died long ago. The interstellar visitor simply mirrors that truth in a form we can see, a living emblem of cosmic continuity. While its scientific importance is immense, 3I Atlas has also become a subject of artistic fascination. Painters depict its lonely trajectory through the solar system as a symbol of endurance. Poets write of its endless silence, comparing it to the unspoken history of the universe itself. Composers have even translated its orbital data into sound, turning numbers into harmonies that echo the steady rhythm of its revolution. Each of these interpretations gives shape to a shared feeling that in its isolation, the object reflects something universal about existence. It is not loneliness it represents, but connection stretched thin across time and space. Engineers and mission planners, meanwhile, dream of the technology required to meet it face to face. Traditional propulsion cannot easily reach an object moving on such a distant, inclined path. New concepts involving solar sails, ion drives, or even fusion-powered probes have been proposed. A successful mission would not only retrieve interstellar material, but demonstrate that humanity has mastered the ability to navigate the solar system's outer reaches. It would mark a transition from being observers of interstellar visitors to active participants in interstellar exchange. There is a growing awareness that 3I Atlas might not be alone. Its capture hints at a quiet population of interstellar debris hidden among the comets and asteroids already catalogued. Some of those objects may have been orbiting unnoticed for billions of years, their origins disguised by time. New detection algorithms are being developed to search for subtle orbital anomalies, slight deviations in inclination or velocity that betray an origin beyond the Sun's birth cloud. If even a handful of these are confirmed, it would suggest that interstellar mixing is not a rare event but an intrinsic property of galactic evolution. Such discoveries would redefine the very concept of our solar system. Instead of a closed collection of native bodies, it would be seen as a dynamic ecosystem continually absorbing and releasing material. The distinction between foreign and domestic would lose meaning. The Sun's realm would be a crossroads of the galaxy, where travelers from other stars occasionally pause in their long migrations. In that perspective, 3I Atlas is not an exception. It is the first recognized member of an ongoing invisible procession. The timeline of its capture provides clues to the gravitational landscape of the outer system. Modeling suggests that Jupiter played the decisive role, as its massive gravity can either eject or capture intruding bodies depending on their approach angle. The planet's influence extends far beyond its orbit, acting as a gatekeeper for the inner solar system. Without Jupiter's exact position and motion, 3I Atlas might have passed through unimpeded. This insight strengthens the idea that giant planets are not only architects of planetary systems, but mediators of interstellar interaction. They determine what is allowed to stay and what must continue onward. In this sense, Jupiter's presence makes the solar system more porous, a gravitational harbor capable of holding foreign vessels. As 3I Atlas continues its circuit, the slight gravitational nudges from other planets will cause its orbit to oscillate. Over hundreds of thousands of years, it may shift closer to the Sun or drift outward toward the Oort cloud. These changes happen so gradually that they cannot be seen within a human lifetime, yet they accumulate into vast transformations. The object's destiny is not fixed. It will evolve like a slow melody played out over eons. Some simulations suggest it could remain bound indefinitely, while others hint that one day it might be nudged free again, resuming its journey through interstellar space. Either outcome fits the natural rhythm of the galaxy: capture and release, union and separation, all part of the same cosmic breathing. Even if it eventually departs, the mark it leaves will endure. Dust from its eruptions will linger in the solar system long after the parent body has gone, joining the endless flow of particles that create the faint zodiacal glow seen in twilight skies. Those grains will drift for millions of years, some perhaps falling toward the inner planets. If one were to land on Earth, it would be indistinguishable to the naked eye from ordinary meteor dust, yet under a microscope, it would tell a story of two suns and a journey through the abyss between them. A speck of matter, smaller than a grain of sand, could carry within it the record of an odyssey spanning the galaxy. At a deeper level, 3I Atlas changes the philosophical relationship humanity has with the cosmos. It transforms the heavens from a distant spectacle into a shared environment. The same way a seed carried by wind can bridge two distant valleys, so too can a piece of rock connect stellar systems separated by light years. This continuity suggests that the universe is not a collection of isolated islands, but an ocean of motion, where everything eventually touches everything else. To live within such a universe is to be part of a story without edges. The object's endurance in the solar system will influence how scientists think about time. Human civilization measures progress in centuries, but 3I Atlas's orbit reminds us that nature's rhythm is slower, almost timeless. One revolution may take tens of thousands of years. Within that span, entire species could rise and fall on Earth, yet to the object, it would be a single step. Its perspective, if it could be said to have one, would be that of eternity. It offers a humbling scale against which human concerns seem brief but not meaningless, for in the very act of observing such vastness, humanity participates in it. Consciousness becomes the universe's way of recognizing its own immensity. As technology improves, future astronomers may use gravitational wave detectors and refined telescopic arrays to map the faintest perturbations in its motion. These data will reveal how the Sun's mass distribution, planetary resonances, and even passing stars influence the stability of its orbit. It will become a benchmark for studying how external forces, galactic tides, nearby supernovae, or encounters with molecular clouds affect captured interstellar bodies. In this way, 3I Atlas will help build the foundation of a new science, galactic dynamics at the human scale. At night, when it passes far beyond the orbit of Jupiter, it reflects just enough sunlight for powerful telescopes to glimpse it as a dim, wandering spark. Each photon of that reflected light travels billions of kilometers before striking an optical mirror, then races through instruments to produce a faint image. The idea that we can trace and interpret those few scattered particles of light, turning them into knowledge about a body born under another star, speaks to the triumph of human curiosity. It is as if the universe whispers secrets and we, fragile and finite, have learned to listen. In the centuries to come, when humanity expands farther into space, 3I Atlas may become an early destination for interstellar infrastructure. Mining its resources, though technologically challenging, could provide a test case for processing materials formed beyond the solar environment. The isotopic diversity of its composition might yield rare or unknown elements valuable for advanced energy systems. Its orbit, stable yet distant, could serve as a platform for outer system observatories, stations from which explorers watch both inward toward the sun and outward toward the stars. Thus, what began as a discovery may one day become a foundation for exploration. Even if no such ventures occur, its symbolic presence will persist. Every civilization that learns of it will see in it a reflection of its own journey, a traveler from elsewhere, adapting to a new home. The fact that it remains, untroubled, undestroyed, slowly circling through darkness, offers a quiet reassurance about endurance. It embodies the truth that movement does not mean loss, that to travel is to carry one's origins forward. The universe in its vast quiet has a way of holding on to moments that feel eternal. 3I Atlas now circles within that timeless rhythm, an unblinking presence that continues to remind every observer, scientist or dreamer, that nothing in the cosmos is ever truly isolated. The sun's gravity has drawn it into a slow, endless waltz that will outlast generations, and though its path is invisible to the naked eye, it is now a permanent thread in the cosmic tapestry of our solar system. It exists as both relic and revelation, embodying the continuity between what was, what is, and what may yet be. Its movement cannot be separated from the laws that bind every world together. At every instant, it is in dialogue with the sun's pull, the whisper of distant planets, and the unseen tides of the galaxy itself. Each point along its path is an equation of balance, a story told in the language of motion. That silent story is what gives 3I Atlas its strange power. It unites the abstract precision of physics with the primal wonder of existence. The realization that a piece of matter born under another sun can now orbit ours connects humanity to a narrative larger than any world or civilization could contain. From the moment it was confirmed to be captured, a quiet revolution began in scientific thought. Astronomers who once viewed the solar system as an enclosed family of bodies began to see it instead as an open network, a gravitational port in the traffic of the galaxy. This understanding shifts perspective on how planetary systems interact. They are no longer isolated laboratories of creation. They are nodes in a grand exchange of materials. Between those nodes, millions of interstellar fragments like 3I Atlas drift through the darkness, each one carrying traces of its birthplace. The interstellar medium, once thought to be a sterile expanse of gas and dust, now seems alive with motion and memory. These fragments are like messages written by the stars, scattered across space by the violence of birth and death. Some are ejected by young stars when gravitational resonances fling their debris outward. Others are expelled when binary systems exchange energy. Still others may be remnants of destroyed worlds. 3I Atlas belongs to this multitude, but what sets it apart is its fate. It has found rest within the sun's embrace. It is no longer drifting aimlessly through the galaxy. It has been adopted, claimed by gravity, folded into a new system's identity. The very act of capture reveals how subtle and dynamic celestial mechanics can be. The equations that describe it are intricate beyond ordinary comprehension, depending on precise alignments of mass, velocity, and timing. In a universe governed by chaos, it seems almost miraculous that such a balance occurred. But the miracle lies not in chance. It lies in the abundance of opportunities. Over billions of years, every star captures and releases countless fragments. We are simply witnesses to one that happened within our brief span of awareness. For the scientists mapping its orbit, each new calculation brings a sense of reverence. The object's path is slightly inclined to the ecliptic, tilting across the plane of the planets like a cosmic thread weaving through their regular motions. Its perihelion, the point of closest approach to the Sun, occurs well beyond the inner planets, ensuring it will not disrupt their paths. Yet even from that distance, its presence is enough to add subtle variations to the gravitational balance of the outer system. These small perturbations, almost imperceptible now, will accumulate over millions of years, perhaps influencing the trajectories of comets or the distant particles of the Kuiper belt. The outer solar system, once seen as a quiet wasteland of ice and rock, is proving to be a stage for these long dramas of exchange. Out there, light is faint and time moves differently. Objects travel so slowly that their motion can be measured only over decades. In that realm, 3I Atlas glides like a frozen ghost, barely illuminated, its surface coated in the residue of both interstellar and solar dust. Radiation slowly alters it, darkening the ices, turning once bright minerals into tar-like compounds. These changes are not decay, but transformation. Every second, cosmic rays are rewriting its chemistry, adding to the layered record that spans from its birth to its capture. When future explorers reach it, whether robotic or human, they will encounter not a lifeless rock, but a chronicle. The strata of its crust will reveal epochs, the original materials from its native star system, the scars from collisions during its journey through the galaxy, and finally, the fine frosting of solar dust it has gathered since entering our system. Each layer will tell of a different era in cosmic time, and together they will form a history older than Earth itself. Studying such an object will allow humanity to trace not only where it came from, but also the forces that shape the evolution of all matter in the universe. In the imagination of those who study it, 3I Atlas has already become a kind of ambassador. It carries the message that every corner of the cosmos participates in a grand dialogue of energy and motion. Matter is exchanged, not hoarded. Stars share their materials with one another across gulfs of light years. This continuous circulation ensures that no world is entirely alone. Even the atoms that compose life on Earth may once have belonged to other suns, other worlds, perhaps even other life. That realization dissolves the illusion of separateness. It shows that the story of life and the story of the stars are the same. There is something profoundly intimate about that thought. When scientists look at 3I Atlas through their instruments, they are not just observing an alien object, they are seeing a reflection of their own cosmic ancestry. It is an emissary from the same process that made them possible. Its arrival, though governed by physics, feels almost like a homecoming. The elements it carries, carbon, oxygen, nitrogen, iron, are the same that make up the bodies and minds of those who now study it. In that sense, it is a relative return from a distant branch of the family tree. The growing understanding of interstellar captures like this may also influence how future generations explore the galaxy. If objects can travel naturally between stars, then artificial craft might follow similar paths. Instead of expending vast energy to cross the void, future spacecraft could exploit gravitational slingshots between stars, using the same mechanics that brought 3I Atlas here. The study of its orbit could inspire navigation techniques for interstellar travel, showing that the universe already provides pathways, if only we learn to read them. Beyond science and engineering, the emotional resonance of its capture continues to deepen. Humanity has always searched for signs that we are not alone. And though 3I Atlas carries no intelligence, its presence is still a kind of companionship. It proves that the distances between stars are not unbridgeable. Something tangible has crossed them and remained. It is, in its own way, a witness that connection is possible even across the largest scales of existence. To imagine standing near it is to contemplate time itself in material form. Its surface, untouched by atmosphere or weather, preserves the silence of billions of years. Every crater, every grain of dust upon it is ancient. There are no winds to erase its marks, no erosion to blur its contours. It is pure memory, written in rock and ice. For an observer standing upon it, the sun would appear smaller than the moon does from Earth, yet its light would still cast long golden shadows across the dark terrain. The stars would be sharp and numerous, unblinking in the void. That view would be the closest any being could come to seeing eternity. Some scientists speculate that within its interior, volatile ices may still be preserved from the conditions of its original system. These could include exotic molecules never before encountered in the solar environment. If recovered and analyzed, they might expand chemistry itself, introducing new molecular families that could exist only under the conditions of distant stars. Such discoveries would not merely satisfy curiosity, they could change the foundation of material science, offering clues to the diversity of possible planetary environments across the galaxy. The implications extend even further. If 3I Atlas carries complex organic molecules, long carbon chains, or amino acid precursors, it would suggest that the chemistry of life is truly universal. The seeds of biology would not be confined to any single world, but distributed naturally by the movements of interstellar bodies. Life, or at least its potential, would be an emergent property of the galaxy itself. The object's capture would then become more than a celestial event. It would be a reminder that the origins of life on Earth might trace back to similar wanderers long ago. Perhaps it was fragments like this, entering the early solar system, that delivered the building blocks of biology to a young molten planet. To many thinkers, this possibility redefines what it means to be home. The solar system is not an isolated sanctuary, but a participant in a vast circulation of creative energy. 3I Atlas embodies that exchange. It is both guest and host, foreign matter made native through gravity and time. Its continuing orbit reflects the same principle that underlies existence itself, that all boundaries are temporary and all separations eventually yield to connection. The object's slow transformation under sunlight tells another kind of story. Each perihelion passage strips away a thin layer of its surface, revealing new material beneath. Over millennia, it will lose mass, yet in that loss, it will become more a part of the solar system, its dust joining the streams that flow between planets, its gases merging with the faint breath of the sun's wind. What was once alien will become indistinguishable from native matter. That process is the essence of belonging, to remain distinct and yet to merge, to give of oneself and in so doing to endure. In human culture, such metaphors carry deep resonance. 3. Atlas has already begun to influence art, literature, and philosophy. Its permanence in orbit has become a symbol of quiet endurance, the idea that even what is most distant can find harmony within a larger order. Writers imagine it as a mirror for humanity's own search for place, for the reconciliation between movement and stillness. Painters portray its trajectory as a silver arc against the velvet dark, a thread connecting the unknown to the known. Musicians have composed symphonies inspired by its long elliptical journey, translating the intervals of its orbit into cascading harmonies that rise and fall like gravity itself. In classrooms around the world, young students now learn about it as one of the defining discoveries of their age. Teachers describe it not as a comet or an asteroid, but as a story of connection. They speak of how something once thought impossible, the capture of an interstellar body, became real through observation and understanding. It becomes a lesson not only in astronomy, but in patience, persistence, and the power of looking beyond boundaries. For many children, 3I Atlas represents the moment the universe felt a little closer, the stars a little more reachable. Scientists, meanwhile, continue to model its internal structure. Some simulations suggest it may have voids filled with trapped gases that could form temporary magnetic fields as they interact with the solar wind. If true, it would mean that even small interstellar bodies can exhibit magnetic behavior, miniature analogs of planets, carrying microcosmic versions of the forces that shape worlds. Measuring these interactions would allow physicists to refine their understanding of how magnetic fields operate in low-gravity environments, a crucial step for studying both exoplanets and the origins of magnetic phenomena in early planetary systems. Even its slow rotation holds meaning. A full rotation may take days or even weeks, but this sluggish spin helps preserve its stability. Fast-rotating bodies tend to fracture under their own centrifugal force, slow ones endure. The very stillness that makes it appear inert is what has allowed it to survive its unimaginable journey through space. It is endurance through calm, a principle nature repeats at every scale, from atoms to galaxies. Over thousands of years, cosmic dust will continue to settle upon its surface, softening its contours, darkening its hue. To future observers, it may appear little different from any other captured object, yet beneath that veneer will remain its unique isotopic fingerprint, forever distinguishing it from native matter. The story of its origin will remain written in its atoms, waiting for any civilization advanced enough to read it. It is the perfect time capsule, uncorrupted, untouched by atmosphere, immune to decay. As humanity advances technologically, the study of 3I Atlas may become one of the foundational sciences of cosmic archaeology, the practice of reconstructing galactic history through physical relics. Just as geologists read Earth's rocks to understand its past, so too will future astrohistorians read bodies like this to trace the migrations of matter across space and time. 3I Atlas will be their Rosetta Stone, a record of cosmic interaction that bridges the language of stars. There is also a quiet moral lesson in its permanence. The cosmos, vast beyond comprehension, is full of objects that come and go, collide and vanish. Yet here is one that endures, not because it resisted motion, but because it found equilibrium. In that balance lies a metaphor for existence itself. To survive, one must neither flee nor cling, but move in harmony with the forces at play. The sun pulls, the object yields, and in that yielding it remains. Perhaps that is why its story resonates so deeply. It reminds us that belonging need not erase individuality, that the foreign can coexist with the familiar, that the universe, for all its violence and scale, contains room for serenity. The sight of 3I Atlas gliding through the outer darkness offers a vision of peace in motion, an image of how even in chaos, order can emerge. Millions of years from now, when the shapes of constellations have shifted and new species gaze up at the night sky, 3I Atlas will still be out there. Its path may have changed, its surface weathered, but its essence will remain. It will continue to orbit the sun, carrying within it the memory of the stars it once called home. And whether anyone watches or not, it will keep telling its story. The story of matter that refused to drift forever, that found a place to stay, that became part of something larger without losing itself. In that endless movement, there is an echo of the entire universe. The same gravity that holds 3I Atlas now once gathered the clouds that formed the sun and planets. The same interplay of attraction and inertia that governs its orbit governs the spiral arms of galaxies. It is not merely a single event, but a microcosm of creation. To watch it is to see in miniature the rhythm by which the cosmos sustains itself, cycles of capture and release, of transformation and return. And so it will continue, a quiet beacon of continuity. Long after its discoverers are dust, long after humanity itself evolves into something new or moves on to other stars, 3I Atlas will remain as witness and participant. Its orbit will cross epochs uncounted, its motion steady, its meaning eternal. In every revolution around the sun, it will affirm a single abiding truth that even across the boundless emptiness, connection endures. Beneath the deep stillness of interplanetary space, 3I Atlas continues its slow and patient voyage through the cosmic ocean, gliding along an orbit that now belongs entirely to our solar system. Though the instruments that trace its faint motion register only minute shifts in brightness, its presence has already rewritten what it means for humanity to look outward and call something part of our sky. The sun's light, scattering off the rough contours of that alien surface, now carries with it the evidence of a connection between two stellar histories, one familiar, one so distant it has no name. Each reflection is a whisper across the void, a photon's brief confession that matter from one world has found shelter around another. There is a kind of beauty in the quiet inevitability of its motion. Every second, 3I Atlas follows a path determined by forces far older than any life that watches it. Its new home is not accidental. It is the consequence of cosmic precision. In the vast gravitational field of the sun and its planets, the visitor found a resonance, a perfect chord between velocity and attraction. That balance is delicate beyond measure, so much so that a difference of a few meters per second in its entry speed would have altered everything. Instead of being captured, it would have fled, carrying its secrets back into the endless dark. But it did not. It lingered. It surrendered just enough energy to remain, to circle endlessly as if recognizing in the silent pull of the sun a place to rest. Since its capture, telescopes have observed slight changes in its reflectivity. These minute flickers reveal that its surface rotates unevenly, as if parts of it absorb sunlight while others deflect it. Scientists interpret this as evidence of complex topography, cliffs, ridges, and deep chasms carved by impacts long before it ever approached the sun. Each scar is a relic of some forgotten collision in its native star system, a place where other rocks, other fragments, once collided in the slow violence that forges worlds. When we study its shape, we glimpse the geological memory of another sun. Its surface temperature remains low, fluctuating only slightly as it drifts nearer to or farther from the sun. Even at its closest approach, the heat it receives is weak, barely enough to sublimate the most volatile ices. The gases that escape during these brief warm periods form thin, temporary halos that trail behind it like faint breath in the cold. From Earth, these halos appear as subtle, diffuse glows, only visible through long exposure imaging. In those glowing wisps, astronomers read chemical signatures, traces of carbon dioxide, ammonia, methane, and complex organic molecules that hint at the chemistry of its distant birthplace. These findings confirm what many had only suspected, that interstellar space is not empty but a continuous field of exchange. Every molecule escaping from 3I Atlas adds to that slow diffusion of matter, enriching the solar wind with material never before part of it. Over time, those atoms disperse across the heliosphere, mingling with dust from comets, meteors, and ancient planetary debris. Eventually, some of them will fall into the atmospheres of planets, including Earth. The process is almost unimaginably slow, yet inexorable. It means that, at this very moment, tiny fragments of another star system are drifting through the sunlight above us, invisible but real. This knowledge changes how humanity understands home. The solar system, once thought of as a boundary, now feels like a threshold. Every star, in its lifetime, gathers and releases matter, trading the ingredients of creation with its neighbors. What we call interstellar travel happens naturally all the time, slowly, silently across spans of millions of years. 3I Atlas is a single example made visible to our brief moment of awareness, but it is part of an ancient rhythm. To realize that our sun has captured something from another world is to see that the galaxy itself is a vast, living network. As the years pass, detailed mapping of its trajectory continues. Each measurement refines our understanding of how interstellar bodies move when they fall under a new sun's influence. The object's orbit is long and elliptical, stretching far beyond the planets before curving inward again. Its aphelion reaches into the domain of the Oort cloud, where trillions of icy fragments drift in the half-light between stars. Some of those fragments may themselves be from other systems. Others may eventually escape, continuing the cycle. 3I Atlas, by joining their number, adds one more strand to the web of gravitational interactions that bind stars together. The capture of this object also carries practical consequences for astrophysics. For decades, models of solar system evolution relied on the assumption that all major bodies formed from the same primordial disk. But the presence of an interstellar component complicates that picture. It suggests that even during formation, the sun may have exchanged material with nearby stars in its birth cluster. Our planets, including Earth, might therefore contain subtle chemical fingerprints of other suns. The discovery of 3I Atlas has reignited the effort to identify those signatures, leading researchers to re-examine isotopic ratios in ancient meteorites and lunar samples. Early results already hint at minute anomalies, small differences in nitrogen and oxygen isotopes that cannot easily be explained by local conditions. Perhaps they are echoes of past captures, ancient cousins of the visitor now circling above. Beyond chemistry, its long-term orbit offers a window into the future of gravitational dynamics. The outer solar system is influenced by passing stars, molecular clouds, and galactic tides that slowly distort its shape. By monitoring 3I Atlas over centuries, scientists can measure those external effects directly. It becomes a tracer for the subtle forces that tug at the sun's realm from beyond. Each deviation in its orbit, however slight, will record the whisper of distant gravity, a message written in the slow drift of a wandering stone. Its capture has also inspired new thought about how the galaxy recycles its matter. Stars forge heavy elements in their cores, then scatter them in supernova explosions or through stellar winds. Those elements condense into dust and ice, forming new planets and moons. Occasionally, pieces are ejected, becoming travelers like 3I Atlas. When such travelers are captured, they close the loop, returning stardust to the cycle of creation. The galaxy, therefore, behaves less like a collection of isolated systems and more like an organism that breathes, inhale, exhale, capture, release. The permanence of 3I Atlas within the sun's gravity is a frozen moment in that respiration, a pause between breaths. Human emotion inevitably colors our understanding of such events. It is impossible to contemplate a journey spanning millions of years without feeling something akin to reverence. The distance it has traveled exceeds any measure of imagination, yet the laws governing its motion are the same that shape our tides, guide our satellites, and govern the fall of an apple. In recognizing that shared order, one senses the quiet unity that pervades all scales of nature. The same force that bends the path of a pebble on Earth also holds an interstellar traveler in the sun's embrace. It is tempting to imagine what this object has seen. In its wanderings between stars, it must have passed through regions of brilliant nebulae, through clouds of hydrogen glowing pink and violet in the light of newborn suns. It may have crossed the outer reaches of countless systems, glimpsing alien planets that will never know its name. Perhaps it skirted the edges of supernova remnants, gathering layers of exotic particles as it drifted through shock waves of light and dust. Every journey left its mark. Every encounter shaped the spectrum it now reflects. To study it is to read a travelogue of the galaxy, written in minerals and ice. There are researchers who believe that 3I Atlas may eventually teach us how common life's ingredients truly are. Already, spectroscopy reveals the presence of organic compounds, simple molecules that, under the right conditions, could serve as precursors to biology. These compounds form naturally in the cold of interstellar space, where cosmic rays and ultraviolet light rearrange carbon and hydrogen into more complex structures. When trapped in ice, they remain stable for millions of years, waiting for warmth to awaken their chemistry. If such molecules exist on a body that originated elsewhere, it means that the seeds of life are not bound to a single region of space. They are woven into the fabric of the galaxy, carried on comets, asteroids, and fragments like this one. The philosophical implications are immense. If the raw ingredients for life travel freely between stars, then the emergence of life may not be an isolated miracle, but an inevitable consequence of cosmic evolution. Planets form, capture organics, and given time, awaken into living worlds. The visitor's arrival thus becomes a reminder that life's story is written not only in the DNA of Earth, but in the movements of stars and stones. To look at 3I Atlas is to look at the continuity of creation itself. Its study has also refined how we think about interstellar travel for future civilizations. By understanding the conditions under which an object can be captured or retained, scientists can design spacecraft trajectories that mimic those natural pathways. The concept of gravitational shepherding, long theorized, gains new plausibility. Perhaps one day, human-made probes will follow the same kind of orbit, entering a foreign system not by brute force but by surrendering velocity in just the right way, allowing a new sun to draw them in gently. The galaxy, once seen as impassable, begins to reveal its own built-in navigation routes. Even the faint light of 3I Atlas contributes to our understanding of the cosmos. Its reflection patterns help calibrate telescopic instruments used to detect distant exoplanets. Because its surface is of non-solar origin, it provides a baseline for interpreting the signatures of other systems. The more precisely we know its properties, the more accurately we can read the light of unseen worlds. In this way, the object becomes both subject and tool, expanding human vision in directions not previously imagined. Over time, as it continues its orbit, the gravitational influence of other planets will occasionally shift its course. Jupiter, the solar system's great mover, may nudge it slightly inward or outward. Saturn's faint pull might alter its inclination by fractions of a degree. These perturbations ensure that its path will never be perfectly predictable. Yet this unpredictability is itself instructive. It demonstrates that even in a system governed by precise laws, there remains room for complexity, for patterns that unfold only through vast timescales. 3I Atlas is a testament to the harmony between determinism and chaos, order and change. The light that reflects from its surface will continue to travel across space, reaching telescopes, cameras, and perhaps the eyes of beings who will come long after us. Each photon carries the memory of that encounter, the sun's radiance, the texture of alien rock, the echo of a journey across the stars. When those photons strike a detector on Earth, they collapse the distance between worlds. The observer becomes part of the same system, connected by the simplest of exchanges, light meeting eye. In that moment, the divide between human and cosmic dissolves. Even its name, 3I, Atlas, carries a quiet symbolism. The number marks its place in a lineage of interstellar discoveries, while the word Atlas evokes the myth of the figure who bore the weight of the heavens. The name feels fitting, for this object truly does carry the heavens upon it. The dust of other stars, the memory of forgotten suns, the burden of eternity. It has endured cold and radiation, drift and collision, and yet remains whole. Its resilience mirrors the resilience of the universe itself, which constantly transforms but never ceases to exist. One of the more subtle effects of its capture has been psychological. Humanity has long seen the solar system as an island, a self-contained realm in a vast ocean, but the permanence of 3I Atlas blurs that boundary. It implies that the solar system, too, is part of a larger migration, a stop along the galaxy's ever-turning wheel. In this realization, people find both humility and connection. We are not the center of anything, yet we are also not apart. We exist within the same continuity that carried this object across light years. That awareness reshapes how humanity understands place, identity, and belonging. The next great step will be to reach it physically. Plans are already being imagined for missions that might intercept it in the far future, using advanced propulsion systems capable of matching its trajectory. The technology required will demand innovations in endurance, communication, and power generation, fields that, once mastered, will open the door to true interstellar exploration. Thus, 3I Atlas becomes not only an object of study, but a destination, a challenge, a promise. Even if those missions take centuries to realize, their planning connects present generations to the far future. To design a mission for something that will be in the same orbit thousands of years from now is to extend human thought across epochs. It is an act of faith in continuity, the belief that knowledge and curiosity will endure as long as the object does. The story of 3I Atlas, then, is not only about what it is, but about what it inspires: patience, persistence, and a sense of belonging to something vast and enduring. It circles still, silent and immutable, marking time not in days or years, but in cosmic cycles. Its journey reminds us that permanence is not stillness, but rhythm, the endless repetition of motion that never truly ends. Long after the records of its discovery have faded, long after languages have changed and civilizations have transformed, it will remain. Its orbit will continue to trace the delicate balance between freedom and binding, between motion and rest. It is the perfect emblem of existence itself, a traveler who found a home among the stars. 3I Atlas drifts now in a silence so deep it defies metaphor. Around it, the solar wind moves like a whisper of breath, an invisible current carrying the heat and magnetism of the sun outward into interstellar space. The object floats within this luminous tide, neither resisting nor surrendering completely, its trajectory a harmony between opposing forces. Every centimeter of its path is written in gravity's handwriting, yet it remains a body of mystery, a relic from a star whose light may no longer even exist. The revelation that it has chosen, or rather been chosen, to remain within the sun's gravitational reach is an epical moment in the human understanding of the cosmos. It marks not just a scientific event, but a shift in perspective. To look at it through the lens of the telescope is to confront the immensity of time. Light reflected from its dark surface has been altered by cosmic radiation, filtered through centuries of dust, weakened by distance, and finally focused into human instruments. That faint glimmer is all we have to study, yet within it lies a map of untold journeys. Spectroscopy can decode the fingerprints of atoms, but not the history of their becoming. To imagine that story is to venture beyond equations, into the slow unfolding of cosmic drama, into the unknowable stretches where 3I Atlas was born. In its home system, it might once have been part of a planetesimal belt, circling a young star with others like it. Perhaps collisions scattered fragments into interstellar space. Perhaps a close stellar encounter tore it loose, flinging it toward the void with just enough speed to escape. For eons it traveled unclaimed, its surface recording the slow accumulation of galactic dust and radiation scars. It would have seen the dim light of nebulae and the blue-white glare of massive stars. It would have passed through clouds dense with gas and regions nearly empty of matter. And then, at last, it crossed the invisible frontier of our solar system, a border defined not by walls, but by the subtle shift of gravity's voice. Its capture was an act of perfect timing. The sun's gravity alone could not have done it. Such a delicate exchange requires the influence of a massive planet. Jupiter, the giant of the solar system, likely played the decisive role. When 3I Atlas entered the solar domain, it must have passed near Jupiter's orbit at a precise angle. The planet's pull slowed it just enough, bending its trajectory into a bound orbit instead of letting it escape. The physics of this encounter are intricate, but the result is simple. What was once a wanderer became a member of the sun's family. From that moment forward, the visitor became subject to a new rhythm. Its path now intersects the domain of other worlds. Occasionally, as it loops through the outer system, it drifts near the regions populated by distant comets. It does not collide. It moves too slowly, too carefully, but its presence alters the gravitational web ever so slightly. These tiny influences are cumulative. Over thousands of years, they may shift the orbits of other small bodies, creating subtle ripples that propagate through the solar system. In this way, 3I Atlas becomes not merely a guest, but a participant in the solar dynamic, adding its mass, however small, to the endless dialogue of motion. Its physical nature fascinates researchers. High-resolution imaging suggests that it is irregular in shape, perhaps elongated like a spindle, or maybe a cluster of boulders bound by their own weak gravity. Its color is a muted reddish gray, typical of bodies exposed to cosmic radiation for immense spans of time. The outer layer of its crust is believed to be a dense, carbon-rich material, formed as radiation altered simpler compounds into more complex ones. Beneath that shell may lie ices, water, methane, ammonia, frozen so hard they are more like rock than ice. Inside it may hold minerals unfamiliar to Earth, forged under pressures and compositions foreign to our solar chemistry. Each new observation adds a fragment to the portrait, but the whole remains elusive. Even the most powerful telescopes can only glimpse it as a faint dot against the stars. To truly understand it would require a mission, a spacecraft designed to meet it face to face. Such a mission would have to travel immense distances, endure years of cold and darkness, and operate autonomously far beyond current human experience. Yet the reward would be profound. A handful of dust from its surface could answer questions about the birth of stars, the chemistry of distant worlds, and the exchange of matter across the galaxy. The object is more than a body of rock and ice. It is a message, a preserved syllable in the language of creation. If one imagines standing upon its surface, the scene would be both haunting and magnificent. The sun, distant and small, would hang like a bright star in a sky utterly black. No atmosphere would scatter the light, no wind would stir the dust. The only sound would be the faint tremor of one's own motion transmitted through the boots of a spacesuit. Every step would be slow. For gravity, there would be almost non-existent. The horizon would curve sharply, revealing the vast emptiness beyond. Stars would burn unmoving in every direction, their brilliance sharper than any seen from Earth. It would be a place of perfect stillness, the kind of silence that seems to erase time itself. Yet that stillness is deceptive. Beneath the inert surface, atomic activity continues. Cosmic rays bombard the material, splitting molecules, rearranging atoms, creating new compounds. Over millennia, this process transforms the chemistry of the crust. The darkening we see from afar is not decay, it is metamorphosis. Each interaction between radiation and matter writes another line in the story of the cosmos. Through 3I Atlas, humanity witnesses that story unfolding in real time, the continuous alchemy of the universe turning dust into the archives of memory. The object's motion also helps scientists refine models of interstellar migration. By analyzing its velocity and direction at the moment of capture, astronomers can trace its probable path backward across space. That trajectory points toward a region near the constellation Lyra, a cluster of stars born around the same time as the Sun. Perhaps it came from one of those systems, ejected during their early chaotic years. If so, its capture completes a loop spanning billions of years. a fragment from a sibling system returning home to the family of stars born from the same primordial cloud. The realization deepens the sense of cosmic kinship. The sun and the star that gave birth to 3I Atlas may once have been neighbors in a stellar nursery. Now, after an eternity apart, their offspring have met again. The permanence of its capture is almost poetic. The orbit it follows is stable for at least tens of millions of years, perhaps longer. Even as the solar system evolves, as planetary orbits drift and the sun slowly brightens, 3I Atlas will continue its slow dance. Its motion embodies endurance. It teaches that permanence in the universe is not achieved by stillness but by balance, a balance between motion and pull, between the will to travel and the gravity that calls one home. Philosophers and writers have begun to find meaning in this balance. For them, the story of 3I Atlas mirrors the human condition. Each person, like that wandering object, begins in a place of origin, travels through vast distances of experience, and seeks belonging in the gravity of connection. The capture of the interstellar body becomes a metaphor for finding harmony in a universe defined by motion. It suggests that even in the infinite, there are places where trajectories converge and become something lasting. In artistic circles, the imagery of 3I Atlas has sparked a new wave of cosmic expression. Painters use swirls of dark and pale pigments to evoke its slow revolution around the sun. Composers translate its orbital period into cycles of sound, a deep hum, a rising chord, a fading echo. Poets write of its loneliness, but also of its peace. There is an entire generation of artists who see in it a symbol of endurance beyond sorrow, movement beyond chaos, and belonging without possession. For them, the captured wanderer is a quiet emblem of unity, the universe itself finding wholeness in diversity. Back in the realm of science, the data continues to reveal surprises. Observations from the outer solar probes detect minute variations in the surrounding magnetic fields when 3I Atlas passes nearby. This suggests that it may carry a remnant magnetization, a faint memory of the field that surrounded its birth star. If confirmed, this would be the first direct evidence of a preserved magnetic signature from another solar system. Studying it could teach physicists about the magnetic histories of stars and how such forces influence the formation of planets. In this way, the object becomes not only a messenger of matter, but of magnetism, carrying with it the invisible imprint of its lost sun. The possibility that 3I Atlas holds clues to the nature of planetary formation is especially tantalizing. Within its interior, there may be a record of how materials clumped together in the early days of its native system. The distribution of metals and silicates could show whether that system was richer in carbon or oxygen, colder or warmer, younger or older than ours. Comparing those ratios to similar measurements from comets and asteroids in the solar system could reveal how different conditions across the galaxy produce different kinds of planetary environments. Such knowledge would expand the understanding of how common Earth-like worlds might be, and how varied the paths of evolution can become. As the years unfold, 3I Atlas becomes a kind of cosmic companion to humanity's own unfolding journey. Each new observation, each refined calculation, adds depth to the shared narrative of exploration. It stands as a reminder that the story of discovery is not a series of disconnected moments, but a continuum, each generation adding its own layer of understanding to the great structure of knowledge. The object's unchanging presence in orbit mirrors that continuity, a silent anchor around which human curiosity can orbit. It is easy to forget that in cosmic terms, the time since its discovery is no more than an instant. Long after current instruments have faded, new civilizations may still be studying it, their telescopes peering through the same darkness, asking the same questions. The idea that knowledge itself can become immortal through such continuity gives the discovery a spiritual resonance. Science becomes not just a tool but a lineage, each era handing its wonder to the next. There are those who speculate that one day, 3I Atlas might be visited not by human explorers, but by artificial ones, autonomous probes designed to survive millennia. These machines, perhaps powered by sunlight or by the faint energy of the interstellar medium, could rendezvous with the object, drill into its crust, and transmit its secrets across space. They would carry no emotion, no fear of time, only purpose, the continuation of the dialogue between mind and matter. In such an encounter, the story of exploration would reach a new level. intelligence born of one star communing with matter born of another. Even if such missions remain far in the future, their conception alone changes how humanity sees itself. To imagine reaching an interstellar body is to acknowledge that the boundaries once thought insurmountable are in fact porous. The capture of 3I Atlas is a natural event, but it opens the door for deliberate connection. It says that stars do not exist in isolation. Their offspring mingle, their dust intermixes, and now their creations, both natural and sentient, begin to bridge the distance. The long-term evolution of its orbit remains a subject of fascination. Over tens of millions of years, galactic tides will slowly alter the orientation of the solar system relative to the rest of the Milky Way. As the Sun moves through different regions of the galactic disk, the gravitational influences around it will change. 3I Atlas, sensitive to those shifts, will adjust its path accordingly. Perhaps in some distant epoch, it will be nudged outward again, freed from the Sun's hold, resuming its voyage among the stars. If that happens, it will carry traces of our system, the isotopes of solar wind, the dust of planetary collisions, back into the galaxy. It will leave as it came, but changed, enriched by its time here. In that sense, its capture is not an end, but a chapter. It is part of the endless circulation of cosmic matter, a dance of arrivals and departures, of inheritance and legacy. Each star, each planet, participates in this exchange, knowingly or not. 3I Atlas has simply made that truth visible, turning abstraction into presence. Far beyond the edge of the visible planets, where sunlight stretches thin and the blackness of space becomes an almost tangible presence, 3I Atlas continues its endless, slow pilgrimage. Its orbit carries it through regions few human instruments have ever glimpsed directly, places where particles move sparsely, where the pressure of the solar wind diminishes into whispers, and where silence becomes a kind of substance. Out there, everything happens in slow motion. Light from the distant sun takes hours to reach its rough surface, and when it does, it reflects weakly, bouncing off a crust that has known no warmth for billions of years. Yet that faint gleam is enough to connect it to us, a flicker of kinship across unimaginable distance. Each time it loops through the farthest reaches of the solar system, its story continues to evolve. The object is not static. Even at the edge of stillness, change persists. Cosmic dust settles upon it like snow that never melts, particle by particle. Over centuries, these grains fuse into a thin layer of darkened carbon compounds, transforming its surface chemistry. Micrometeor impacts chip away at its crust, exposing deeper layers that have not seen light since its birth. Through such slow abrasion, the visitor records the passage of cosmic time as surely as rings record the life of a tree. The outer heliosphere where it travels is not a void, but a sea of charged particles, stretched thin and shaped by magnetic forces. When 3I Atlas moves through this plasma, it creates ripples, subtle distortions that reveal information about both itself and the environment. Sensitive instruments aboard distant probes have begun to detect these fluctuations, providing rare data on how interstellar bodies interact with the solar wind. In a way, 3I Atlas has become a scientific probe without design, a natural instrument through which the universe measures itself. As its presence endures, so too does its mystery. Even now, astronomers debate the exact nature of its composition. Some models suggest it contains silicates, similar to those found in the inner solar system, hinting that its parent star may have shared properties with our own sun. Others propose that it formed in a colder, darker environment, perhaps on the outskirts of a red dwarf system where ice dominates rock. If true, it could contain exotic compounds, frozen gases, and minerals unseen in any local body. Each hypothesis speaks to a different birthplace, a different childhood among the stars. The truth, for now, remains unspoken, sealed within its ancient shell. The more closely scientists study its motion, the more they come to understand the hidden architecture of the solar system. The sun's domain is not a static bubble, but a living, breathing sphere whose boundaries expand and contract with cycles of solar activity. Every 11 years, the magnetic field of the sun flips, reversing polarity and sending waves of energy outward. When these waves reach the distance of 3I Atlas, they alter the flow of charged particles, briefly brightening the thin glow of ionized gases around it. Through these faint pulses, astronomers can observe the rhythm of the solar heartbeat carried to the farthest edge of its influence. The permanence of its orbit gives rise to new possibilities. For planetary scientists, it offers a benchmark against which future changes in the solar environment can be measured. By tracking its path and velocity over centuries, researchers can record how the gravitational balance of the solar system shifts as planets move and masses redistribute. 3. I-Atlas becomes a kind of cosmic clock, its unwavering motion marking the deep time of celestial mechanics. Long after human calendars have changed beyond recognition, its steady revolution will still keep perfect measure of the sun's dominion. From a philosophical standpoint, its presence provokes a reconsideration of what home means. Once, humanity believed the solar system to be a closed system, its materials born together, evolving together, bound to one origin. But the arrival and permanent residence of something from beyond that boundary proves otherwise. The sun's family has expanded not by design but by the natural generosity of gravity. This inclusion reveals that belonging is not about where something starts but where it stays. 3i Atlas, though foreign in origin, is now part of this stellar household as surely as Earth or Jupiter. In its slow procession, it sometimes passes near regions populated by dormant comets. Those comets, distant cousins of planetary formation, share with it a kinship in composition but differ in story. Some were born close to the sun and cast outward by gravitational tides. Others lingered at the margins, waiting for eons before being stirred. The interactions between these ancient bodies, though rare, shape the outer solar system in quiet ways. Occasionally, one comet's faint gas tail brushes the path of another, exchanging molecules invisibly. It is conceivable that 3i Atlas too will share material this way, a silent mingling of dust between worlds. If one could compress time and watch from afar, the region beyond Neptune would resemble a ballet of slow, intricate choreography. Thousands of dark objects trace looping, intersecting orbits, each governed by the sun's subtle command. Among them, 3i Atlas moves with distinct purpose, its inclination slightly off the plane of the ecliptic, giving it a unique rhythm. This tilt allows it to rise above and dip below the orbital plane of the planets, offering a perspective no other major body shares. From that elevated vantage, the solar system appears not as a flat disk, but as a luminous spiral of motion. To imagine the view from there is to glimpse creation in motion, a wheel turning endlessly in darkness, each planet a spark in the spokes of light. At the heart of scientific fascination lies the question of how such interstellar objects might influence planetary defense strategies. Understanding how the sun captures a body from another system can help predict the paths of future visitors, some of which might not be as benign. If an object of similar origin but larger mass were to enter on a different trajectory, it could alter the balance of orbital dynamics in profound ways. Thus, studying 3i Atlas not only satisfies curiosity, but strengthens foresight, offering models for how the solar system might respond to future encounters. The field of astrobiology also finds reason to look to it with hope. Within its frozen core may lie compounds that once existed in the protoplanetary disks of other stars. Those compounds could include prebiotic materials, organic molecules that, if delivered to a world with warmth and water, might awaken chemistry into biology. The idea that life's seeds drift between stars like spores in a cosmic wind gains new weight when a captured interstellar object can be studied up close. Even if 3i Atlas contains no living matter, its chemistry might tell us whether the conditions for life are widespread or rare. Its long-term stability also invites speculation about its eventual fate. Over millions of years, gradual gravitational perturbations might shift its orbit inward, drawing it closer to the inner planets. If that occurs, sunlight will grow stronger, and the frozen compounds on its surface may begin to sublimate more vigorously. Jets of vapor could erupt from fissures, creating a transient tail that glows faintly against the stars. For a brief time, 3i Atlas might resemble a comet, a luminous visitor visible from Earth with the naked eye, a symbol of connection between worlds. Then, as its new orbit stabilizes, the tail would fade, leaving the core intact, a survivor of its own awakening. But even that potential transformation would take place over ages longer than any civilization has yet endured. For the foreseeable future, 3i Atlas remains a creature of the outer darkness, where cold reigns eternal. And yet, even from that remoteness, its existence exerts a quiet influence on human thought. To know that it circles the sun is to feel that the universe is less distant, that the space between stars is not empty but alive with stories like this. Unseen bridges connecting one cosmic neighborhood to another. Astronomers studying its reflectivity have noted an intriguing pattern, a periodic dimming and brightening consistent with rotation. This rotation period suggests that it turns on its axis roughly once every several days. The irregular shape causes sunlight to scatter unevenly, producing the light curve observed from Earth. This slow spin hints at a body that has endured countless impacts, each one subtly altering its angular momentum. Such evidence paints a portrait of resilience, of an object shaped by violence yet made whole through endurance. Over the centuries, as new technologies arise, the precision of our measurements will increase. Future telescopes stationed beyond Earth's orbit may capture direct images of its surface. From these, scientists could map its craters, fractures, and possible boulder fields. The study of these features would reveal not only its geological past, but also the history of collisions in interstellar space. We might find that its surface bears the fingerprints of events that occurred before the Sun itself existed, a pre-solar record written in stone. For humanity, the discovery and permanence of 3I Atlas mark a threshold in perception. It changes how we see the solar system, no longer as an isolated pocket of matter, but as a crossroads in the galactic current. If one object could arrive and stay, then surely others have come before and will come again. The idea that the Sun occasionally adopts interstellar visitors transforms the notion of cosmic solitude into one of quiet company. We live not in isolation, but in the midst of a slow, invisible migration of worlds. That revelation alters even the poetic imagination. Writers have begun to envision civilizations that might have arisen on planets around the star from which 3I Atlas came. They imagine the beings who might once have looked up at their own skies, unaware that a fragment of their system would one day orbit another sun. Perhaps those imagined watchers once studied their own comets, just as we now study this one, never knowing that the paths of both civilizations were destined to cross in the faintest of ways. Such imaginings lend the object a sense of kinship beyond science, linking us to the unknown through wonder itself. For philosophers of science, its capture serves as a reminder of how chance and law intertwine. The universe is not purely deterministic nor purely random. It is a tapestry woven from both. 3I Atlas followed natural laws, but those laws required coincidence, a moment of perfect alignment for capture to occur. Out of countless possible trajectories, one intersected the narrow gateway into the Sun's hold. That intersection mirrors the improbabilities that shape existence itself, the chance alignments that give rise to stars, planets, and eventually, consciousness. In studying the orbit of an alien rock, we glimpse our own improbable survival written in another form. The psychological impact of its permanence cannot be overstated. Humanity has always sought signs of permanence in a transient universe. Mountains erode, seas shift, civilizations fall. Yet here is something that will endure beyond all memory. It will continue its orbit when the Earth's continents have fused into one again, when the oceans have receded, when even the constellations have changed shape. To know that something so small, so silent, will persist long after us is both humbling and strangely comforting. It suggests that even as life and culture change, the story of the cosmos goes on unbroken. Through the vast and unending corridors of the solar system, 3I Atlas continues its stately revolution, an unhurried witness to the quiet breathing of the sun. The object remains invisible to the human eye, a dot too faint for most telescopes to easily resolve, yet its presence is undeniable. It is a rhythm written into the gravitational music of the cosmos, a single note sustained in the symphony of stars. No other human discovery in recent memory has offered such a profound merging of scientific revelation and philosophical depth, for 3I Atlas is not just a rock or an ice fragment, it is an emissary from another creation story, one now bound eternally to our own. Far beyond Neptune's orbit, where the warmth of the sun becomes an idea rather than a reality, 3I Atlas circles in dignified silence. The darkness surrounding it is nearly absolute. Only the faintest shimmer of sunlight glances off its ancient crust. Yet that crust, blackened and scarred by the eons, carries secrets no human world has ever known. The object's surface preserves, molecule by molecule, the chemistry of a distant sun's debris field. Its minerals are locked in crystalline matrices older than the planets of our solar system. If one could hold a piece of it in their hand, they would be holding time itself, compacted into something tangible, a relic of an era before Earth even existed. Every few months, new measurements refine our understanding of its orbit. Its path has proven to be more complex than first imagined. Subtle interactions between it and the outer planets produce periodic shifts in velocity, creating oscillations that are almost musical in their regularity. Jupiter's massive gravity tugs faintly each time it nears the outer resonance of that planet's path. Saturn contributes its own influence, slightly distorting the orbital eccentricity. These gentle perturbations form a dialogue between the newcomer and its adoptive system, a conversation conducted entirely through motion and mathematics. Within those fluctuations lies information about the unseen. By analyzing how 3I Atlas responds to planetary forces, astrophysicists can infer the density and distribution of matter at the fringes of the solar system. It acts as a natural probe, feeling out the contours of the sun's domain in a way no spacecraft could match. The precision required to measure such effects is extraordinary. Fractions of arcseconds, tiny shifts in reflected light, delicate changes in trajectory. Yet each one deepens the understanding of how gravity weaves invisible connections across space. The object's stability is so profound that it challenges previous models of orbital mechanics for interstellar captures. The prevailing theory once suggested that such captures would be temporary, mere pauses in a body's passage through the sun's gravitational field. Yet 3I Atlas disproved that assumption by settling into an orbit predicted to endure for millions of years. The process that led to its permanence reveals a universe of unexpected balance. The Sun, Jupiter, and Saturn together formed a gravitational triangle at just the right moment to cradle the wanderer, bleeding away enough of its velocity to transform it from trespasser to resident. The precision of that event defies ordinary probability. It required a choreography of forces so intricate that it seems to border on intention. Still, its story is no miracle of fate. It is an expression of abundance. The galaxy is immense, and its currents are ceaseless. Over billions of years, fragments like 3I Atlas are ejected from systems, cross the void, and are occasionally welcomed into others. The rarity of seeing such an event lies not in its uniqueness, but in the brevity of human observation. We exist in a momentary sliver of cosmic time. The universe, on its own scale, performs these exchanges as routinely as the tides move upon Earth. The capture of this interstellar traveler simply allowed humanity to notice, for once, what has always been happening. The influence of that realization extends beyond astronomy. Philosophers have drawn parallels between the cosmic and the human, the way both are shaped by the interplay of motion and belonging. Just as a star's gravity can transform a wanderer into a companion, so too can human experience bind what was once alien into something cherished. 3I Atlas, in its quiet orbit, has become a symbol of that reconciliation. Proof that foreignness does not preclude unity, that difference can become harmony under the right conditions. Meanwhile, planetary scientists continue to debate the possibility that this object may contain isotopic ratios not found anywhere else in the solar system. If future missions ever reach it and return samples, those ratios could serve as fingerprints identifying its birthplace. With enough data, it may be possible to trace it to a specific star cluster or even to an individual stellar nursery. Such a breakthrough would turn it into a literal messenger from a distant system, a physical connection across the gulf of space between two suns. The concept alone transforms the human imagination. The idea that one could trace a rock from a different sun orbiting within our own sky is both poetic and revolutionary. Beyond the physical and the scientific, 3I Atlas occupies a unique emotional place in the human story. In ancient times, the sky was thought to be immutable, its stars fixed and eternal. The appearance of comets, meteor showers, or novae always brought astonishment, sometimes fear. Now, in the age of data and mathematics, that sense of wonder has not diminished. It has matured. The discovery of a permanent interstellar visitor rekindles the same awe that early humans must have felt when they first looked upward and saw movement among the stars. It is a reminder that even with all our instruments and theories, the universe can still surprise us, still reach out from its depths and offer something entirely new. The significance of 3I Atlas also extends to future exploration strategies. Its orbit provides an opportunity, a potential gateway to the outer solar system. By studying its motion and composition, engineers can design missions that use similar trajectories for energy-efficient travel. The gravitational pathway that captured it might one day serve as a template for spacecraft seeking to move between solar systems. In this sense, it becomes not only an object of study but a map, a demonstration that nature has already solved problems humanity has yet to master. As the years pass, our perception of the object will evolve alongside technology. Perhaps in centuries to come, when propulsion systems can sustain long-duration missions, explorers will approach it directly. They will find its surface a labyrinth of impact scars, cliffs, and plains of black ice. They will anchor instruments in its dust, drill into its heart, and bring forth frozen gases that have never before met the warmth of a sun. When those gases sublimate and escape, they will briefly form a halo around the lander, a thin spectral veil, the breath of a world reborn. That image will become a symbol of human perseverance, a meeting between the oldest traveler and the newest explorers. Even without direct contact, the object continues to inspire. In literature, it has become a motif for continuity, a reminder that the universe carries its own memory, that every journey leaves a trace. Artists have painted it as a glowing ember adrift in a sea of night, its long trajectory symbolizing both exile and belonging. Musicians have composed pieces that mimic its slow rotation and orbital rhythm, layering tones that rise and fade in cycles that mirror its cosmic heartbeat. Each interpretation extends the discovery beyond science into the realm of feeling, where facts become metaphors and truth deepens into meaning. In classrooms, students study 3I Atlas not only for its data, but for what it represents. The idea that the boundaries of the known are always expanding. Teachers speak of it as evidence that the universe is not static but alive with movement and exchange. They explain how every atom of carbon and oxygen in the human body once passed through the heart of a star, and how, through objects like this, that cycle continues. Children learn that the very matter composing them might one day drift into another system to form new worlds, new lives. Thus, the discovery becomes part of education's grand narrative, a lesson not of isolation, but of cosmic kinship. Astronomers also use 3I Atlas as a model to refine the search for future interstellar visitors. By understanding how it moved before capture, scientists can predict what signatures to look for in telescope data when similar objects approach. This knowledge may one day lead to a network of detection systems positioned throughout the solar system, watching for incoming wanderers. Each new detection would expand the archive of interstellar material available for study. Eventually, humanity might build an entire taxonomy of such objects, a record of the galaxy's migrations written in stone and ice. But even as science progresses, there remains a quieter truth about this captured traveler. Its presence reveals that motion and belonging are not opposites but complements. It did not cease to move when it was captured. It found a new pattern, a new rhythm defined by the sun's gravity. In the same way, the act of discovery does not end curiosity, it reshapes it. Each answer found leads to deeper questions. Each orbit completed invites another cycle of observation. The permanence of 3I Atlas is thus a mirror for the persistence of inquiry itself. Long after current generations have gone, future ones will inherit its watch. They will recalibrate instruments, compare their data with the records left by their predecessors, and find in the faint variations of its orbit a connection across time. For them, 3I Atlas will be more than an astronomical object. It will be a legacy of continuity. Each measurement they make will echo the first observations made centuries earlier, a chain of understanding linking one era to the next. In this way, the captured wanderer becomes a bridge not only between stars but between moments in human history. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on 3I Atlas staying in our solar system? We want to hear from you. Thank you for watching and see you next time.